Very good morning, all my dear friends. Welcome to yours Unacademy NEET English channel. I'm your HSP Baba, Magical Chemistry Group. So, first of all, I would like to see that everyone can hear me, can see me. So, here is your HSP Baba. So, today we are going to deal with the most awesome, it's fantastic chapter. That's benzene, aromatic, aroma, pleasant smelling compound. So I can see that everyone is over there. Deepti is here. Ravina is here. Gaming FF. Very good morning. Kids, if I'm perfectly audible and visible to each and everyone, then show me the green signal. You know the drill. How to show the green signal that yes, my voice is reaching up to you. Yeah, that's really fantastic. I can see everyone that the Shari is here. Sneha is here. Very happy morning, Sneha. Deepti is here. So, warm welcome to each and everyone. So, today's lecture holds a hell lot of weightage. If I say that this is the chapter, the benzene reaction, that means at least 30% of organic chemistry, 30%, 1, 2, 3, 0, 3 into 10, 30% of the organic chemistry is based on this most important, very important chapter. Mohammed, Desari, Arthi, everyone, very good morning, all my dear friends, lovely students. And your presence means the best present ever I could. Now, so if you are new, if anyone is new, let me give you a brief introduction of myself. I'm being Haren Singh Parihar, did MTech in 2004 and MSc Gold Medalist in 1999. After MSc, I cleared GRF and GATE. And for the last 23 plus years, I have been teaching for IITJEE and NEET, whatever the medical entrance. Reduced number of ranks, mass selections, top 10 ranks, first rank, third rank, fourth rank, like that. But I'm being the positive catalyst. It all depends on your hard work. The one who is doing hard work definitely is going to get selected. So today, the very first lecture of benzene. Just try to understand what is benzene. MS Chauhan book, yeah, that was good in old days, but nowadays it has become obsolete. Nowadays, whatever the questions practice we are going to do on this board, HSP means me. I'm going to give you those questions which are expected, and definitely questions will come from here only, whatever the questions I'm going to give you, because NTA is there. Now NTA has changed each and everything. MS Chauhan book was good when there was AIMS exam. AIMS was taking separate exam. At that time it was good. So without any delay, let me start. So this is your HSP, and if kids you are new, then subscribe the channel, and I can see likes are very less. If you love your HSP Baba, if you love the teaching of HSP Baba, very fine teaching, and this teaching is going to give you the selection in your examination, then hit the like buttons. I won't see the likes should get increased as the number of students are getting increased. Likes, yes, smash the like buttons, and if you're new, then subscribe the channel. Okay, so let me start without any delay. This is your benzene. Let me draw benzene. You must have seen the thumbnail. There is benzene. So do you know what is this? Everyone, do let me know what is this. What you're going to call it? Everyone, because I'm not in a hurry. Number of students are thinking that just do this and that. Whatever you are going to deal with, do it in a proper way. You should understand the basic thing. Once the basics are clear, each and everything will be cleared, kids. Now, do let me know what is this. PG Vijay. PG Vijay, Vishnu, welcome to each and everyone. Sai, just do let me know what is this. So, if you're saying that this is being benzene, those who are saying that this is being benzene, then your answer is going to be wrong. Examiner will give you big zero for benzene. It is not benzene. Now you will say, sir, what are you talking about? We have to study it from so many years that this is being benzene. No, kids. If this is being benzene, then never anyone is going to say name of benzene. So everyone must be saying that 1, 2, 3, 4, 5, 6. Cyclohexa 135 triene. They must have called it cyclohexa 135 triene. This should be the name. If this is benzene, then this should be the name. But if this is the benzene, its expected energy means calculated energy was, expected energy, or you can say calculative energy was 86 kilocalorie per mole. 86 kilocalorie per mole. But kids, actually its energy was found experimentally. We can say its energy was found experimentally. That was the expected, and experimental energy was found to be how much? 50 kilocalorie per mole. 50 kilocalorie per mole. Now, scientists started thinking that we were thinking that this is the energy, but they have got only this much of energy. Everyone just keep in your brain, more is the energy, less will be the stability. Now, kids, you are not able to correlate. Just like if you see H2O, ice form, very stable. Iceberg once collided with the Titanic got destroyed. Same H2O, if it is getting energy, it is becoming H2O liquid, that's being water. Not that much stable, but energy is more. Now, once the H2O liquid, that is the water, is absorbing energy from the atmosphere and the environment, it is going to become as gas. Gaseous form of H2O, that is steam, whatever the thing, water vapors, they are highly energetic. Clouds are highly energetic. They can transfer from one state to another state. They don't have any boundaries. But stability is least. Airplane can go from them. They are not able to do anything. So it's all about energy. So this was the expected energy, but actual energy was found only to be 50. That means benzene is said to be stabilized by, kids, do let me know, benzene is said to be stabilized by. Everyone write down in the chat section, this was expected and this is theoretical. How much less? 36 kilocalorie per mole. And that's why benzene is said to be stabilized by this much. Is energy is less. This is less. That means exothermic reaction. So we call it resonance energy, that is minus 36 kilocalorie per mole. Always resonance energy is negative. Kids, energy is never negative. This negative sign is indicating that this much energy has got released. That's only. So how it is getting resonance, and due to resonance, this single bond is not single bond and this double bond is not double bond. They all are equivalent. So what is this actually? This is one of the famous resonating structure of benzene. This is just RS of benzene. It's not benzene. It's not benzene. Now kids, you must be thinking that sir is going to tell us about electrophilic reaction, electrophilic substitution reaction or something else. But what is this? Sir, it started telling us about benzene only. Kids, if you're not able to understand what actual is benzene, you won't be able to understand anything. If you are able to understand what is this, then you can understand anything. Now let's see. This is the actual structure of benzene. This is the actual structure of benzene, that pi electrons are always moving. Pi electrons are always moving. If I say that if I am provided with any single bond, its bond length is 1.54 angstrom, and double bonded carbons bond length is 1.34 angstrom. So neither single nor double bond, all bond lengths are same. So just remember 1.39 angstrom, 1.39 angstrom. Now if you are unable to learn it, let me tell you how to remember it. A point C I Bahubali, Armstrong, Angstrong. You need to remember, they can give you in picometer also. Armstrong, arms means Bahubali, movie Bahubali. Angstrong, ACI Angstrong. So all carbon-carbon bond lengths are same. All carbon bond lengths are same. Bond lengths are same. Are equivalent, better to say equivalent, and this is due to resonance. This is the actual structure of benzene. This is benzene, actual structure of benzene. This we can say, yes, this is benzene. So what happens? Benzene is having electron clouds which are revolving above the plane as well as below the plane. See how the benzene is actually. Let me draw. This is the carbon skeleton of benzene, and if I just show you the p orbitals, pure p orbitals which are unhybridized, pure p orbital, these are being unhybridized pure p orbitals, and in this the electrons are moving above the plane and below the plane. That means single electron is going here, it's coming down, it's going up, it's coming down, it's going up, it's coming down. That means this electron, if I say this electron is going up, coming down, this electron is going up, going down, same 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 electron is going up and going down. Not only going up and down, you can see the same electrons are moving like this also. They are moving like this also. That means first they are going up, down, up, down on all the carbons, and they are moving like this, and above the plane as well as below the plane, above the plane as well as below the plane. So benzene is said to be stabilized by, benzene is said to be stabilized by, benzene is stabilized by delocalization of pi electrons, delocalization of pi electrons above and below the plane, above and below the plane. Now benzene is having 6 pi electrons which are moving up and down, 6 pi electrons, and it is being planar. 6 pi electrons, that means it is following Huckel's rule, and it is being planar, that means planarity rule. So this is said to be aromatic. And once the compound is being aromatic, its electrons are involved in resonance. It's not easy to attack on these electrons so easily. Although this benzene is electron rich, highly electron rich, highly electron rich, and the entity which is being highly electron rich is known as 6 pi electrons. is known as nucleophilic. It is being nucleophile. But on these moving electrons, it's not easy to attack. It's very tough to attack on these 6 electrons. Definitely, Appuji, I will let you know. I will let you know about isomerism. Now see, everyone see to it that this is our benzene. It is having 6 pi electrons. It is having 6 pi electrons, and it's not easy to attack on these electrons. And benzene is being aromatic, so benzene will not like to show addition reaction. Addition reactions are very rare. So what benzene would like to show? Benzene will undergo electrophilic substitution reaction. This is E plus and this is Nu. Now definitely this is being neutral compound. You can see this is being neutral compound. So this is also neutral. It must be along with some Nu. So delta negative and delta positive. As this is nucleophilus, this is electron rich. This benzene is being electron rich. So which part of that compound will attack? Definitely this E plus part will attack on this benzene, and what is going to happen? This will convert into E and benzene plus hydrogen of that will come along with Nu, H and U. As I have told you, this reaction is not easy. So in the presence of catalyst, some catalyst will definitely increase the rate of reaction. Now, very difficult question. This benzene is having hydrogens and all the hydrogens are being arylic. These all hydrogens, 6 hydrogens are being arylic. 6 hydrogens are arylic. And it's not easy to remove arylic hydrogen. It's very difficult to remove arylic hydrogen. Arylic hydrogens are just like captain of the ship. Now, if I apply CID investigation, then everyone will start saying, sir, something is there. Something is there mysterious, that how this reaction has taken place. Let's try to understand the mechanism, how this reaction is taking place. So see kids, this is electrophilic substitution reaction, and how this reaction is going to take place. Let's see. Let me tell you, this is electrophilic substitution reaction. Electrophilic substitution reaction. Why being electrophilic substitution reaction? Benzene has lost hydrogen and gained E. In place of E, it has lost its hydrogen. How this reaction has happened? All these steps involved in this reaction is known as mechanism of the reaction. So we are going to deal with mechanism of the reaction. Let's see the mechanism of reaction. Each step understanding is known as mechanism of the reaction. Is everyone ready, kids? Is everyone ready? Show me the thumbs up if you are ready to understand the mechanism. What's the mechanism is clear. You can understand each and everything. Kids, show me the Josh. How is the Josh? Everyone, do let me know. Nayana, Arthi, Loyal Man, Trinity. Wow, that's really awesome. So I'm going to tell you the mechanism. This reaction takes place in main three steps. ESR. See how the ESR can be written as. It can be written as ESR, or it can be given as SE, or they can give you electrophilic substitution reaction. Why the name is electrophilic substitution reaction, kids? Why not its nucleophilic substitution reaction? Always the name of reaction is after the attacking agent. Who is being the attacking agent, that should be the name of reaction. It's electrophilic substitution reaction because who is going to be the attacking agent? Electrophile is the attacking agent, because in the examination, no one is going to tell you why the name is like this, who is going to attack, and what you are supposed to do. That is your brain, and in your brain we have to see each and everything. Electrophile is the attacking agent. Electrophile is attacking agent. That's why its name is electrophilic substitution reaction. Do remember that. Who is the attacking agent in this reaction? Everyone, electrophile. So how it will come to your brain that electrophile is the attacking agent? Whenever the reactant is benzene or benzene derivatives, because no one is there in the examination who is going to tell you that what type of reaction is going to take place. So remember that benzene or its derivatives, whenever you see benzene or its derivatives, then definitely in your brain it should come that who is going to attack on this electrophile is going to attack on this, and this reaction takes place in main three steps. These three steps are really very, very important. This reaction takes place, this reaction proceeds in main three steps. Now let's see what are these three steps. These three steps are step number one. Let me write down the reaction. What was the reaction? Reaction was like this. This was our benzene. This was ENU. Now what has taken place? ENU. Now it has lost its H and gained what? It has lost H along with Nu. This delta positive, this delta negative, and this delta positive, and this delta negative, this being delta negative and this being delta positive. So it's just the exchange. You can see this has happened. You can see very clearly that E, H, Nu, and whatever the catalyst you have used at this place, catalyst during the reaction will participate, and once the reaction got completed, it will come in its original shape, size, and concentration. Now, step number one, generation of an electrophile. This is the first step. Generation of an electrophile. Generation of an electrophile. How the electrophile is going to get generated, that's just the most important thing. Now see kids, let me show you. This is being ENU. This is strongly bonded with sigma bond. Although it is having delta positive and delta negative, but still this is sigma bond, strong bond, and sharing of electron. This is being strong bond. So this is not going to break easily. It will require time. So you are supposed to use catalyst. What type of catalyst can be used? Catalyst can be, most important catalyst is anhydrous AlCl3. This is the first choice. Or you can use FeCl3, or you can use FeBr3, or you can use Gen10Cl2, anhydrous ZnCl2, anhydrous ZnCl2, or you can use H plus. Any of the catalysts which are being Lewis acid electron deficient. Lewis acid is the catalyst. Now, why they are being the catalyst? If I talk about anhydrous AlCl3, this is aluminum is having just 6 electrons in the valence shell. See, AlCl3, Al, Cl, Cl and Cl. How many electrons in the valence shell of aluminum? 1, 2, 3, 4, 5, 6. Now you will say how aluminum is having 3. Atomic number of aluminum is 13, 283. Or boron, aluminum, gallium, indium, thallium. Boron, aluminum, gallium, indium, thallium, they belongs to third A group. So they will be having 3 electrons in the outermost shell, only 6 electrons in the valence shell while sharing. So it is in need of electrons. So this AlCl3 will come over here and will say Nu, hey Nu, come along with me. I am in need of electron. I'm in need of electron. You just come along with your electrons. I will take you. I will take you. I will take you. Now, once this has happened, electrophile has generated it has lost its electron. See, this E has lost its electron and it has become E plus, and it has gaining electron, and it will reach to AlCl3 Nu negative. See, everyone comfortable? Do let me know. Everyone comfortable that this is the Lewis acid which was in need of electron, the starving for electron, the hungry for electron. It has started the reaction, and in this way you have got what? Electrophile has got generated. In this way, this E plus got generated. Everyone, till now, everyone, you are able to understand. Kids, communication level should be great. Just once, if you're getting it, show me the thumbs up. Yes, sir. That we are able to understand, because yeah, this is being electron loving. Wow. Basit Hussain, I think you are new. Love from Kashmir. You're liking it? If yes, then do let me know. First thing is generation of an electrophile. In this way, electrophile is getting generated. Now, once the electrophile has got generated, earlier this was electron loving. Now this is electron loving. Now it is saying, oh, my electron has been stolen. Now I am being electron loving. This is being electron loving, kids. Now this is electron loving. Now it has started, oh, please provide me electron. Now this E plus is going to benzene. So that is being the second step. Step number 2. Step number two is kids, attack of electrophile on benzene. This is the most important step. Most important. This second step is the most important step, and this is rate determining step. Why this is rate determining step, I will let you know. But yes, this is the most important step, rate determining step. What is going to happen over here? Attack of electrophile on benzene is going to take place. Attack of an electrophile on benzene. Attack of an electrophile on benzene. Now see why this is being rate determining step and how the electrophile is going to attack. This is the most important thing, kids. Try to understand. Everyone try to understand. This is your benzene, and its electrons are not localized. They are always in moving condition, like a fan. Like a fan, moving condition, it's very tough to attack. But electrophile is saying, oh, benzene, I want to attack on you. Now benzene is saying, oh, you were to not like this. What has happened to you? E plus is saying, somebody has stolen my Nu. My Nu has gone along with Lewis acid. I know, although that Lewis acid will not be able to manage my NU, but he has stolen my NU. Now I'm feeling very hungry for electron. Now I'm gonna attack on you. I will attack on your electrons. I will attack on your electrons. Benzene is saying, oh, E plus, fool man, you won't be able to attack on my electron. I'm being aromatic. My electrons are not like this. They are moving electron. It's not easy. It's not easy. It's not easy to attack. It's not easy for you to attack on my moving electrons. E plus said, I will wait. I will wait for months. I will wait for years. I will wait for a day. But yes, I will attack. I can attack. I'm not going to forgive. Always remember, kids, steps are very tough, but they will take time, but not impossible. Electrophile was there and it was saying, I have to attack, and it has taken too much time. Very slow process. Very slow process. Very slow process, or you can say the slowest step of the reaction, or we can call it slowest step of the reaction. Slowest step of the reaction. But electrophile said, I will attack and I will create delta negative charge. So this bond will move toward this side and there will delta positive, and hence the attack is successful. It took too much time, but electrophile anyhow managed to attack on it, and there is positive charge, and this is electrophile. Now see, kids, this is unstable. This is being unstable. This was stable. This was stable and that is unstable. Do let me know why this was stable and this is unstable. Highly unstable. Why? Highly unstable. Why, kids? Do let me know. It is being unstable. See, everyone, it was having 6 pi electron and this is having just 1, 2, 3, 4, and this carbon is being sp3 hybridized. Neither it is being planar, neither it is being planar, nor it is being aromatic. See, it's not aromatic. Not aromatic. It's not aromatic. That was aromatic. This is not aromatic. So, which is being more stable? This is being more stable. That is being, I would like to say, unstable. So, the reaction is more towards that side and less toward this side, though reversible reaction. This is being reversible step, but more towards that side, less towards that side, towards that, oh, bad, not more toward that side, not more toward that side, wrong, because that is unstable, though it will be more towards this side, more towards that side, less towards that side. See, kids, more towards backward direction, because that is unstable, this is stable. So the reactions, this step will be more towards backward direction, less towards forward direction. Everyone understand? In the starting I said that more towards that side. No, that is less stable. See, unstable. So the reaction is more towards backward direction because this is more stable. So you know that in 1 mole there are 6.023 into 10 raised to power 23 molecules. So there must be number of molecules. When there are number of molecules, electrophile is going to attack on those molecules. Some R is going towards that direction and maximum of the portion of compounds will come towards this direction. Everyone is able to understand? Kids, do let me know that this reaction is coming more in the backward direction. But anyhow, if this is formed, this is not aromatic and this is the intermediate. This is being intermediate. That means this reaction is not taking place in single step. This reaction is multi-step reaction and rate of reaction is directly proportional to the stability of intermediate. Everyone, do let me know that the rate of, this is the rate determining step. Slowest step is always the rate determining step. So rate of ESR is directly proportional to the stability of this intermediate. Stability of intermediate. More the stability of intermediate, more the rate of reaction. So rate of electrophilic substitution reaction is directly proportional to the stability of intermediate. Now, are you ready for the third step? This compound is saying, hey E, you have disturbed my aromaticity. Now I want to take revenge. Revenge I will take, and I want to become aromatic once again. Now see step number 3, everyone. See step number 3. Step number 3. Step number 3 of the reactions mechanism. This step, third step, generally fast, but generally this is fast, but for some reactions, but for iodination and sulfonation, this is very, very important. Sulfonation, iodination and sulfonation, it is fast. Generally fast, but for iodination and sulfonation, it is slow and rate determining. Slow and rate determining. Now, that means RDS means rate determining step. That means for iodination and sulfonation, there are 2 rate determining steps. For iodination and sulfonation, second step plus third step, both are being rate determining step. This is the very, very important point, kids. Do remember that for iodination and sulfonation, second as well as third step, both are being rate determining step. Second as well as third step is being rate determining step. What I'm saying, for iodination and sulfonation, there are 2 rate determining steps. This is going to give you marks, kids. Do remember, for iodination and sulfonation, there are 2 rate determining steps, second as well as third. And if I talk about rest of others, what are they? Chlorination. If I talk about chlorination, bromination, nitration, for these 3, only second step is rate determining. Only second step is rate determining step. Only second step is RDS and third step is fast, not the rate determining step. Third step is fast and not the rate determining step. Kids, these things, these 2 points are really very, very important, and they are tough question. If you don't know these 2 points, you won't be able to solve the tough questions. Kids, are you ready? Everyone ready? Now see, kids, now I'm going to explain this third point, and I'm going to explain the reason also why it is like this. By for iodination and sulfonation, this is slowest step, third step, and for chlorination, bromination and nitration, it is not the rate determining step. See, everyone, just look at the third step. So the third step is like this. This was your unstable compound. It was like this. Here was your electrophile and this was positively charged. Now see, this hydrogen and rest of other hydrogens, is there any difference in the red hydrogens and this orange hydrogen? Is there any difference? All these are attached with the double bonded or plus charge. This one, this one, this one, this one, they are arylic, arylic, and this one is just attached to this olefinic sp2. This is being sp2 hybridized, but the hydrogen is attached to sp3 hybridized. This is being sp3, so this hydrogen is allylic. Allylic bonds are weak bonds. Allylic bonds are weak bonds. This is being weak bond, and these bonds are being stronger bonds. Now kids, let me tell you, the one who has stolen its AlCl3 has stolen its Nu part. Do you remember in the starting, this has stolen its Nu part. Now this ring is saying, hey H, you just get lost. We don't want to see your face and we want an electron. We want to gain electron. If it is going to gain electron, this carbon is going to get negative charge. And negative and positive, they will form bond. So where this H plus will go, this AlCl3 is saying, AlCl3's mummy is saying, you are too small. You can't handle this extra Nu because you are being small. Just keep 3 valency. The 4th valency you won't be able to handle. So give them back their Nu part. So this Nu will go along with this H plus. Now you can see very clearly this is going to form a bond. This is going to form a bond. You can see very clearly what's happening over here. The bond is getting formed. The bond is getting formed. This was already like this. This was already like this. And this was the electrophile. Now negative and positive, there is one. This bond. Now benzene has gained its aromaticity. Now once again this benzene is being aromatic and this has gone with Nu, so it has become HNU HNU, and the anhydrous AlCl3 has come back in its original shape, size and concentration. So people will say that catalyst does not take part in the reaction, but you see during the reaction it was participating in the reaction, but just before the completion of the reaction it has come back in its original shape, size and concentration. So this is being unstable. This is being unstable. This is being unstable, and that is being stable. This is being unstable, and that is being stable. So what do you think? The reaction will be slow or fast? Yes, it is fast. This step is being fast for what? Fast for chlorination, fast for bromination, fast for nitration. Now this step is not fast for iodination and sulfonation. Now question arises, why this step is not fast for iodination and sulfonation? That is the very important point. Kids, are you able to understand whatever I'm telling you? Kids, first do let me know everyone is able to understand, because between you and me only this chat section is the communication level medium. So do let me know in the chat section everyone is able to understand. Kids, do let me know everyone. Are you getting sense? Is this the cramming part or the part to understand? Is this cramming part or the thing to understand, kids? Wow, Everyone is saying yes. That's really awesome that everyone is able to understand. Now, let me tell you why for iodination and sulfonation this step is slow. Everyone see to it. If I say there is iodine as the electrophile, and there is also hydrogen. Now, this AlCl3Nu will come. Now, definitely this Nu is interested in the weak part, weak bond. Now, see which is being weak bond. First of all, we have to understand carbon belongs to the second period. And if I say fluorine, chlorine, bromine, iodine, fluorine, chlorine, bromine, iodine belongs to which period, kids? Iodine belongs to which period? This is second, third, fourth, fifth. So this iodine belongs to 5p, this carbon belongs to 2p. This bond is very weak bond, very weak bond, and this bond is having percentage of ionic character. The single bond has some ionic character, and this single bond is also having ionic character. Weak bond. Both the bonds, this and this, both bonds are being weak bonds. Both this one and this one, both bonds are being weak bond. Both are being weak bonds. Why both are being weak bonds? One is being hydrogen and one is being iodine. Iodine 2p and 5p weak bond. So this Nu will take away this iodine. If Nu is taking away this iodine, positive, so negative and positive will form a bond. From where they have started, they will go to benzene only, means the same reactant. From where the reaction has been started, it will go back at the original, they have reached to the original reactant. So this reaction is going in the backward direction. This is the backward direction. And if this H plus in some of the reactants, this H plus will get removed. If this H plus got removed by Nu, then the reaction will proceed in the forward direction, and the forward direction says you will get product as this one. So the reaction is moving in the forward direction as well as backward direction. So reaction is going in both the direction. So this step is slowest step. This is being forward direction, forward step, and this is being backward direction, backward step. So kids, what was the problem with iodine? Iodine size is too much, overlapping is bad, and sulfur is also 3p. So sulfur and iodine's bond is weak, and that's why the step is being slowest step. Everyone got it? Same case with the sulfur as with the iodine. Now let's start. Types of ESR. How many types of ESR are there? Types of ESR, just to let me know. Anyone? Types of ESR. Types of electrophilic substitution reaction. How many types do you know? Everyone do let me know. How many types of ESR do you know? So number of types of ESR are H, N, S, A, coupling, gutterman. Now, these are the types of ESR. H stands for, kids, do let me know. H stands for halogenation. N stands for nitration. S stands for sulfonation. This A stands for Friedel-Crafts alkylation. This A stands for Friedel-Crafts acylation. Acylation. Now, how many types of ESR are there which we are going to deal with? 1, 2, 3, 4, 5, 6, and 7. There are total 7 types of electrophilic substitution reaction which we are going to deal with. Is everyone ready? So we are going to see what are these reactions and what is being their reaction mechanism. So everyone ready? Ready. Kids, always sit with your proper energy. Don't think that whether I'm going to get selected or not. Always believe on the process. In the process, if you are believing, then the goal will be definitely you are going to reach your goal. You are going to achieve your goal. So believe in process. Everyone now see, I'm going to start with halogenation. The first step is being halogenation. Just see halogenation. So how many halogens do you know? Definitely the reactivity order will be like this. Fluorine is being maximum reactive, then chlorine, then bromine, and iodine is being the least reactive. This is the reactivity order. Everyone agreed? So this is being the reactivity order. Now, this fluorine is maximum reactive, sometimes explosive. So fluorination cannot be carried out. Fluorination can't be carried out, can't be carried out, can't be carried out because of explosive nature, because of explosive nature. Now, examiner will ask question, then if fluorination is not able to carry it out, then how can you prepare fluorobenzene? This is the best question of the exam. Any, yes? Anyone who can suggest me how will you prepare fluorobenzene? Gopika Shri, very good morning. Very good morning. Is there anyone who can let me know that how can fluorobenzene be prepared? Then do remember, always remember that fluorobenzene is prepared by Ball-Schiemann reaction. What's that? This is your benzene diazonium chloride plus HbF4 and heat. If you're going to heat it, you will get fluorobenzene, and this reaction's name is Ball-Schiemann reaction. The examiner will ask, if the fluorination of benzene cannot be carried out, then how will you prepare the fluorobenzene? So remember that this is known as Ball-Schiemann reaction. What is the name? Ball-Schiemann reaction. Ball, B-A-L-C-H, Ball, S-H-I-E-M-A-N-N, Ball-Schiemann reaction. This is the way how the fluorobenzene is prepared, and the examiner will definitely ask this question. Now, chlorination and bromination is really very well. We can prepare it. Now see how the chlorination is carried out. Everyone see to it how the chlorination is carried out. Chlorination. If you are able to understand chlorination, you can understand bromination. Chlorination. You just take benzene plus Cl and Cl and take anhydrous aluminum chloride. Anhydrous AlCl3. AlCl3. Then what you are going to get? You will get chlorobenzene plus HCl, and once again your AlCl3 will be originated back. Now, how this reaction must have taken place? Let me tell you. Wow, very good, Satvik, Chintrapudu. That's really fantastic. Now see, The reaction must have happened. The first step, this anhydrous AlCl3 must have taken away its Cl negative. I'm not going to tell you all these steps because the general mechanism I've told you. So, first step, this chlorine plus must have originated. In the second step, that chlorine plus must have attack on the benzene. Then the benzene, yes, this Cl plus must have originated in the first step. Then the second step, this chlorine plus must have attack on the benzene, and benzene has lost its aromatic character. That is going to be the second step. And in the third step, that unstable carbocation is going to release proton. And in this way, this reaction has happened. But now, my dear students, if I react with excess of chlorine, if I react with excess of chlorine, the same reaction, if I am going to deal with 1 Cl2, 6 moles of Cl2, if I react with 6 moles of Cl2, so whatever is happened once, that is going to happen 6 times. 6 times. And what product you are going to get? Kids, do let me know. You will get this product. Is there anyone who can let me know what is the name of this product? Is there anyone, kids? Is there anyone who can let me know what is the name of this product? What it is going to called as 6 times HCl. I'm waiting for your answer. What is this? Is very, very important compound. Everyone, do let me know what is the name of this product. Let's see whether you are going to crack NEET or not. I'm dead sure that your answer is going to be wrong. Is there anyone who is going to let me know what is the name of the product? Kids, I'm waiting for your answer. Everyone, I'm waiting for your answer. Do let me know what is the name of product. Hey, everyone, I'm waiting for your answer. What is the name of the product? Let me check it out whether you are able to give me the correct answer or not. Is there anyone? No one? No one. So, no problem if you are not able to tell me. That was chlorobenzene. That was chlorobenzene. Its name is chlorobenzene. So, definitely its name is hexachlorobenzene. 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 But why I have stayed over here? Why I have waited for the name, kids? I'm going to let you know. This is very, very important reaction and dangerous reaction. This reaction has to be proceeded in dark. Darkness is required in dark. Now, why I'm talking about dark is required. So this is definitely ESR reaction, electrophilic substitution reaction. But most of the time, students are getting failed. 99.9% cases, students are often getting failed. See why? Let me tell you. See, everyone focus over here. Everyone. If you talk about this reaction, just see to it. If you talk about this reaction, three times Cl2 and the temperature is given. See, there was dark. There was dark. Here, 500 Kelvin temperature or UV, ultraviolet rays. If I talk about 500 Kelvin, this is the heat. So I will talk about thermally. This reaction is carried out thermally. That means in presence of temperature. And if I talk about this, this is photochemically. Photochemically. Now, you see in that reaction, benzene was there and chlorine was there. Both are the same thing, but product is not going to be same. Why? This is going to be a product. I'm slow right now. because I want to tell you something very, very important. I'm going to let you know very, very important thing. This is the point where most of the students are getting failed. Just see over here. These are chlorine, Cl, 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 and still the hydrogens are also there. Hydrogens are also there. What's the difference between that reaction and this reaction? Try to understand, kids. Everyone, just try to understand what's the difference between that reaction and this reaction, the previous reaction and this one reaction. Just see, it is not benzene. This is a very, very important point. You see, that reaction was benzene. It was benzene. It is benzene. Benzene, it is benzene. That means it is being aromatic. Aromatic. This is C6 and Cl6 because its hydrogens has eliminated out. This is just C6Cl6. Focus over here what I am trying to tell you, kids. C6Cl6. But if I talk about this reaction, this is C6H6Cl6. That means during this reaction, the C6H6 has gained 6 chlorine atom and no atom has been removed. This reaction has taken place on the basis of this double bond. These pi bonds has been lost. Pi bonds has been lost. Focus over here, my kids. Pi bonds has been lost in this reaction. During this reaction, pi bonds has been lost. This was benzene. This was benzene. This is the question for assertion and reasoning 3 times. AIMS. This question has been asked in AIMS 3 times and 4 times in IIT. So assertion reasoning question. Let me tell you what type of question they are going to ask. Bonds has been lost. This is benzene and this is being aromatic. This is being aromatic. But kids, it's not aromatic. Do remember, it's not aromatic. It's not aromatic. Not aromatic. Now, why the students are getting failed? It's being not aromatic. It's not benzene. It's not benzene. Let me tell you, it's not benzene also. It's not benzene, but its name is benzene hexachloride. What's the name? It's a general name, it's a trivial name. Its name is benzene hexachloride. This is the name. Benzene hexachloride is the name. It is given in NCERT. Benzene hexachloride is the name. In short form, people used to say BHC. They are calling it BHC. Now, the examiner will ask, and already it has been asked, benzene hexachloride. See the assertion. See the assertion. Benzene hexachloride is aromatic. And the reason is it follows planarity rule and the Huckel's rule. What do you say? Benzene hexachloride is aromatic. True or false? Assertion, benzene hexachloride is aromatic. True or false? False. Now, most of the students will say, yes, it is true. Assertion is right because name is benzene hexachloride. But benzene hexachloride is the name, but it's not benzene. It's not benzene. So, and it's another name. Let me tell you other names for this compound. Other names are gamexene. Another name are gamexene. Gamexene powder is there. Gamexene. Another name lindane. Lindane. Another name 666 C6H6Cl6. So these are the another names for this compound. So remember, these two reactions are very, very important reaction, and don't get confused. And this is not electrophilic substitution reaction. This is actually electrophilic addition reaction. This is electrophilic addition reaction. It's not ESR. It is actually electrophilic addition reaction. Let me tell you, this is electrophilic. This is no, it's temperature, so not electrophilic, free radical addition reaction. I will not say electrophilic because we have provided high temperature. So this is free radical addition reaction. Free radical addition reaction, because this reaction is carried out in presence of high temperature. So free radical addition reaction. Free radical addition reaction. So if in the exam it is given electrophilic addition reaction, that is the wrong statement. Free radical addition reaction. Everyone is able to understand. Everyone is able to understand. Now let me tell you, let me ask one question. Everyone see to it and try to understand and try to give me the answer. If this reaction is given, this is benzene, and if they are giving these two reactions, see two reactions. One reaction is being, they have given Cl2 excess anhydrous AlCl3 is given, and in another reaction what they have given, they have given Cl2 excess, and here 500 Kelvin temperature is given, and there dark has been mentioned, dark. So do let me know in which reaction you are going to get aromatic. Everyone do let me know, sir, what is your breakfast? What is that breakfast? So why breakfast? You are asking about breakfast. That is just, you can say, the sprouts I used to take, sprouts. Now kids, do let me know what you are going to get over here and what you are going to get over there. Everyone do let me know. Here I will get benzene. First important thing, benzene. Cl, 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 Cl. This is an example of electrophilic substitution reaction. Electrophilic substitution reaction. And what I am going to get over here, so in this I will get benzene. No, it's not benzene. I will get HCl. I will get HCl. I will get HCl. I will get HCl, get HCl and HCl. It's not benzene. Its name is benzene hexachloride, but it's not benzene. BHC, BHC. That is being aromatic, and this is not being aromatic. Always remember, here it is being aromatic, but this is not aromatic, not aromatic. Clear to all of you? Not aromatic. Number of times this question has been asked. Now that was ESR, and this is free radical addition reaction. Free radical addition reaction. Is it clear to each and everyone? Hare Gopika Shri, lunch, dinner, don't ask about that. I'm very simple person. I'm not the right person to guide you about my lunch, breakfast and dinner. I'm a very simple. Thank you, Buddha Shurya sir. You are looking very handsome. Oh my God. Naina is asking, second is not aromatic. Why? See, Naina, there is no pi electrons. No pi electrons. There are, that is following planarity rule and Huckel's rule. The first one is following planarity rule. It is doing planarity rule it is following, and it is following Huckel's rule. It is having 6 pi electrons. 6 pi electron, both the two rules. It is being sp3 hybridized. Neither it is planar nor it is following Huckel's rule. No, neither it is being planar nor it is following Huckel's rule. So this is not aromatic. Kids, clear to each and everyone? Is this point clear to each and everyone? Now kids, always have plenty of water and try to walk, and in the morning try to do meditation. I'm 50 years old, kids. I'm on the right side of 50, 49 point something, that 50 years old, and see, yeah, Buddha Shri, you can see double bond equivalent lecture, then you will come to know. Now, right now, I have told you about chlorination. The mechanism of bromination is same as that of chlorination, but let me talk about iodination. See, iodination, everyone see iodination. If I talk about iodination, this is your benzene, and if I react with I2, this is going to react with I2, and now see what's the problem. This is, here is, we can use Lewis acid, and the reaction will come more in the backward direction, less in the forward and more in the backward. What's the problem? Because carbon is saying I am being very small. Carbon says I am being very small. I am just 2p and you are 5p. Oh my god, too much energy gap. One is small, carbon is very small, and iodine is very big. Carbon is saying, what is this? Iodine, you are too much big. Iodine is saying, oh, how can you talk like this? You are very small. So their bond is very weak. Gopika Sri is saying, oh my god, you are 50. I can't believe. Yes, I'm 50. I'm 50. No one is going to believe, but yes, I'm 50. 23, for the last 23 plus years I have been teaching. I did my class 12th in 1994. Now see kids, this bond is very, very big. Very big bond. Very big bond. Very poor overlapping. So this bond is weak bond. Weak bond. Bond is being weak. So this reaction will come in the backward direction because this is formed and this HI is formed. This I and that I will react and this will come in the backward direction. So the yield is very poor. Examiner will say yield. Yield will be very poor. Yield is very, very poor. Now, if you want to prepare iodobenzene in good yield, if anyone wants to prepare iodobenzene in good yield, what they have to do? Wow, Shelva Kumar is saying, guys, trust me, he's really an energy house. Thank you, kids. Thank you. Now, I need your support. I'm new to this channel and new to YT. So, I need everyone's support, kids, if I'm teaching well. And that I know because I've produced number 1 rank, number 3, number 4, number of ranks. If you see my history, number of ranks has been produced by me. So everyone, you have to share and you have to be consistent. Okay. Hometown, my Chandigarh and Lucknow, 2 places I belong, Chandigarh and Lucknow. But right now, come back kids, let me complete this. Now, how to increase the yield? Question arises, how to increase the yield? Now, yield can be increased. Yield can be increased, or this statement can also be given as that equilibrium can be, or we can say equilibrium can be shifted in the forward direction. In the forward direction, equilibrium can be shifted in the forward direction. But how? Now kids, this reaction is coming back by taking this HI's iodine. This iodine is taking the support of this iodine of HI and that is going back. Anyhow, if we remove this HI, this reaction won't be able to get back. Yeah, Tanishka, yeah. If anyhow, if we remove this HI, if anyhow this HI is going to get removed from this reaction, then equilibrium will go in the backward direction. Won't be able to go. Now this HI, just see what is this HI. Either way, I can say HI is an acid, as well as I will say on HI, iodine is having -1 charge. So this is very good reducing agent also, as well as reducing agent. Now we know that if this is acid, we can add base, and if this is reducing agent, we can add oxidizing agent. So equilibrium can be shifted in the forward direction by two ways, either adding base or adding oxidizing agent. Now, out of these two things, which is being better? Now, let me tell you which is being better. If I'm going to add base, definitely any base will react with this, and due to acid-base neutralization, salt and water will be formed. Acid-base neutralization, salt will get formed, right? Salt and water. Now, better than this is inferior method. Why this is being inferior method? Let me tell you, this is being inferior method. So superior one is being just to HI, HI is being reducing agent also. It is being reducing agent also. So you have to add strong oxidizing agent. SOA means strong oxidizing agent. What a strong oxidizing agent will do? Strong oxidizing agent, you just add strong oxidizing agent like HNO3, you can see HNO3 oxidation state is 5, or HiO3 is +5. Now you see they are being strong oxidizing agent. Once they are going to react with this HI, they will produce I2 plus water, and this is the really best method. Why it is being really best method? See here, I2 was the reactant, and this was the product. Whenever there is equilibrium, one scientist always jumping, just take my name, just tell these students, Lee Chatelier principle. What Lee Chatelier principle says, let me take one more page to explain it. So this was the reaction. There was too much congested. If I write down this reaction over here, the I2 at this place, and if I tell you that this reaction is going to take place and it is going to form HI, and this reaction is in equilibrium. So Lee Chatelier principle says if product is eliminated out and reactant is added, equilibrium will go in the forward direction. It's so scientist Lee Chatelier, Lee Chatelier says that if product is eliminated out, if product is eliminated out, and more the reactant added, equilibrium will shift, more in the forward direction, Now, if I'm going to add over here HNO3, this is in maximum oxidation state. So this HNO3 will react with HI. This HNO3 will react with HI to give I2. Now you see the product is getting consumed from the reaction and reactant is getting formed. Equilibrium will go in the forward direction. In this way, you will get maximum amount of product. Kids, everyone is able to understand. So if the examiner is asking how the yield of iodobenzene can be increased, so this is the answer and you have to tick it so that you will get full marks. Everyone, now let's move towards nitration. Let's move towards nitration. But before moving towards nitration, I'm going to give you one question. That question is for top 50 rank. How many of you are ready for top 50 rank question? This question is not going to be easy. This question is going to be tough. Question for top 50 rank. Question for top 50 rank. Everyone ready for this question? Question is, compare the rate of reaction. Compare the rate of reaction. What are the two reactions? See, the two reactions are like this. This is your benzene plus chlorine Cl2 to give you product chlorobenzene. Chlorobenzene. Now, if I give you another one, this is deuterated benzene. In place of hydrogen, there are deuterium. You know isotopes of hydrogen, protium, deuterium, tritium. So this is being deuterated benzene. Deuterated benzene. And the reaction with Cl2 is carried out to give you deuterated chlorobenzene, deuterated chlorobenzene, deuterated chlorobenzene. So suppose the rate for this one is R1 and the rate for this is R2 and the same concentration. So the options I am going to give you, the first option, the second option, the third option, fourth option. First option is being R1 is approximately equal to R2. Second, R1 is greater than R2. Third, R2 is greater than R1. And fourth, we can't say. We can't say. So here the four options given for this reaction, and this question is for top 50 rank. That means for AIMS Delhi. Let's see what answer you are going to give, kids. Everyone, do let me know. Yes, I'm waiting for your answer, kids. Everyone, do let me know what's the answer. So, most of the students are going to give what answer? I know what answer you are going to give. Your answer will be B1, but this is wrong answer. Never give this answer. Most of the students will give B answer, right? You see, maximum students will give B answer. But that is wrong answer. Why it is wrong? And the correct answer is this one. A is the correct answer. Let me tell you why. You see, whenever I was telling you the mechanism of the reaction, you do remember second step was the rate determining step. And in second step, H or D was not getting lost. Just to remember, for this reaction, second step was the rate determining step. Do you remember? Second step was the rate determining step. If you remember, kids, do let me know. If you remember, for this reaction, second step was rate determining step. Second step is RDS, and in the second step, neither H nor D has been lost. Neither H nor D was lost. So rate will be equal, R1 will be equal to R2, or we can say KH will be equal to KD, or we can write KH by KD will be equal to 1. That means if you change the isotope, rate of reaction will not get changed. On changing the isotope, rate of reaction is not getting changed. So no, or we can say will not show isotopic effect, will not show isotopic effect, isotopic effect. Now, if the same question like this has been asked like this, see, once again I am going to give you rank deciding question and try to understand. If the question was given like this, once again, rank deciding question. If the question was given like this, see everyone, this is benzene and iodination is carried out, iodination. This is deuterated benzene. Try to focus everyone. Very, very awesome questions. Number of times the questions has been asked in your definite particular type of examination. One is being benzene, one is being deuterated benzene. And if this reaction is being carried out and they are giving you these products, this is iodobenzene and this is deuterated iodobenzene. Deuterated iodobenzene gets. Now, if I say this is R1 and this is R2 and the options are given as R1 is approximately equal to R2, R1 is greater than R2, R2 is greater than R1, we can't say. Now, what should be the answer? For this reaction, what should be the answer? Now, definitely what you were thinking. Now, you know, for this reaction, the answer will be R1 is greater than R2, because for this reaction, second as well as third step, both are being RDS. Both are being RDS, rate determining step. And you know that in the third step, H is going to leave and D is going to leave. And the bonding, if I say carbon to protium bond length is like this, protium bond length is like this, and carbon to deuterium bond is like this. Which bond is stronger? Carbon to deuterium bond is being more stable. More the mass, more is the strength of bond. So deuterium is not going to lose easily. So this bond is stronger. Stronger bond will require more time to break. This is being a stronger bond. So now in short, let me tell you, for those students who are not able to understand this much, let me tell you the trick, HSP Baba's trick. Let me give you HSP Baba's trick for those students, those who are not able to understand anything. So, trick by HSP Baba trick. See, whenever you are going to deal with any question, do remember chlorination, bromination, nitration. These are the three things which will not follow isotopic effect. That means R1 will be equal to R2, or we can say KH by KD will be equal to 1 and will not follow isotopic effect. Will not follow isotopic effect. Whereas if I talk about yes, what is left? Kids, do let me know what is left. So if I talk about iodination and sulfonation. So for these two cases, yes, definitely will follow isotopic effect. And for these two cases, KH by KD will be greater than 1, because protium bond will easily eliminated out and deuterium will require more time. So this thing is clear. Now nitration is very, very important. Everyone ready? How's the Josh? Do let me know. I'm going to deal with nitration, the very, very important thing. So everyone ready? Gopika Shri, don't worry. Tell your friend that attend HSP Baba's lecture. I am teaching from the 0 level up to the top rank. I'm the one who always teaches, yes, from 0 to top level, right? Now, nitration. Everyone try to understand nitration. Nitration. See what is going to happen over here. In this nitration, we are supposed to react our benzene. Zoom. This is being benzene plus concentrated HNO3. Why concentrated, sir? I will let you know. Plus concentrated H2SO4. Oh my god, this is also being concentrated. Yes, both are being concentrated. Then it will react to give you product. What is the product, sir? The product will be nitrobenzene plus water plus H2SO4. Oh my god, sir, H2SO4 was taken on reactant side also, product side also. What is this, sir? Then why you have taken H2SO4? Just cancel out, sir. Over here and there, just you cancel out. Okay, kids, I will let you know what is the reason now. This concentrated H2SO4 and concentrated HNO3, they are known as nitrating mixture. What they are known as, kids? Nitrating mixture. They are known as nitrating mixture. So why they are known as nitrating mixture? When both of them combine, they will produce nitronium ion. Which ion, kids? They are going to produce nitronium ion. What is that? NO2 plus. This is the actual reactant or the attacking agent, known as nitronium ion. The actual attacking agent, the actual electrophile. Oh my god, sir, how this is happening? I will let you know the mechanism. During this reaction, this HNO3 act as base. Oh my god, this will act as base, Base. Oh, is this a movie, sir? This is acting as base, and this will act as an acid. Oh my God, sir! Both are being acid. What are you talking about? This is acting as an acid, and that is acting as a base. What's going on, sir? How we are going to understand one is acting as acid, one is acting as a base? 90% questions will be coming from here only. See, kids. Now, I'm going to explain each and everything word by word, step by step. So, are you ready? Gopi Sri is saying, last year I took drops by paying, oh, lakhs for AIMS, New Delhi. By that teaching is not like you. Thank you. Thanks from the internal core of my heart, kids. If you're liking my teaching, I'm a very simple but hardworking with two postgraduate degrees. One is being MSc, another one is being MTech. Okay, so Hanumaka, Hanumaka, wow, Noel man, wow, that's really awesome. And if you're liking it, call your friends. If they are going to see it, if they are going to watch my lecture, definitely kids, I'm teaching from zero level and going up to the best level required for your first rank. Oh my God. Now see, are you ready for the mechanism? Everyone ready for the mechanism? Now see, what's the mechanism? If I talk about mechanism first step, mechanism's first step, what was that? Mechanism first step was generation of an electrophile. Generation of an electrophile. Do you remember? Generation of an electrophile. Let's see. Let's talk about that. Generation of an electrophile. You just see how many things are there. There is one flask. Let me take one flask. Let me take one flask. There is one flask. This is one flask. How many types of entities are there? Whenever you want to understand chemistry, just don't think what teacher is telling you, what is written in the books. Try to understand with your brain. Apply your brain. See, how many types of entities are there? There are three types of entities. Concentrated H2SO4. Second type of entity is concentrated HNO3. Third type of entity is in the solution. Yes, benzene. Benzene. Now all the three are saying, just give your intro. This is saying I'm electron rich. Benzene is saying I'm electron rich. I'm electron rich. Everyone say that I'm nucleophilic. I'm richy rich. I'm rich in electrons. So I'm richy rich. My name is nucleophile. Nucleophile. All the electrophiles I attract. I used to attract all the electrophiles. These two are saying I'm acid, I'm acid. HNO3 is saying I'm acid, HNO3 is saying I'm acid. Now, benzene said, hey, who is being stronger acid? H2SO4 said, yes, I'm the stronger acid. So I'm going to donate proton. So H2SO4 has released its proton. Why? Because this is being stronger acid. So it has released proton. Kids, are you able to understand? Now, as H2SO4 being stronger acid, it has released its proton. Now others have to accept this proton. Benzene is saying, I'm not interested in your proton. Whatever you are going to release, that's none of my business. That's your business. Who is going to accept? HNO3 is saying, oh, I was acid, but in front of you, H2SO4, I cannot act like as an acid because you have released proton. Now I'm going to accept that proton. Now see, this HNO3 will accept this proton. So this proton will come towards HNO3. Now see how this HNO3 is going to accept proton. The one who accepts proton acceptors are known as what? Proton acceptors are known as base, and proton releasers are known as acid. Now see how the reaction is going to proceed. So we can see very well this H2SO4 is going to release proton. H2SO4 has released proton. This proton has been released by H2SO4, so it's looking like H positive, HSO4 negative, and that proton will be accepted by whom? This proton will be accepted by HNO3, that is being NO2OH. We can write HNO3 like this, NO2OH. The oxygen's lone pair is going to accept the proton released by that. So by accepting this proton, let's see what is going to happen. This H plus is going to attack on this lone pair and it will convert into NO2 O positive H2. Now the plus charge originated on oxygen. Oxygen will say, oh, wow, Anju Singh is liking that, really good. Now oxygen will say, I can't tolerate this positive charge. I am being that much electronegative. I can't tolerate this positive charge. Now see, once oxygen cannot tolerate this positive charge, so it will say, oh, just get lost. Who should get lost? Water. Water should get lost by taking electron of oxygen. Oh, great. So it's getting eliminated. So in this way, NO2 plus, you got NO2 plus water. Now see, if I combine all these things, but before that, let me write down this is acting as an acid. This is acting as a base because proton acceptor. And if I combine all together, you can see what is getting eliminated out. You can see very clearly that this NO2 plus is getting cancelled out with this. This proton is getting cancelled out with this because on the reactant side, product side, reactant side, product side, what is being left? Do let me know. H2SO4 is being left, right? You can see H2SO4 is being left. So this is being H2SO4. HNO3 is left. This is being HNO3. Take care because one question is going to come over here which has been asked. So keep it in your brain. This reaction is being reversible. This reaction is being reversible. And once the reaction is being reversible, so this HSO4 negative is there. This NO2 plus is there. And this water is being there. You see, this is the thing which we have got. Now, once the question in 2016 has been asked, that was a really awesome question. What was the question? Before I give you the question, just see, there is equilibrium. Whenever there is equilibrium, which scientist will say, just tell each and everyone about me. Whenever there is equilibrium, one scientist, Le-Chatelier's principle will be applicable. Le-Chatelier's principle that says, if you remove water and if you add more and more these things, reactant, then reaction will go in the more forward direction. Why we want more forward direction? See everyone, we are interested in more forward direction because we are interested in NO2 plus. This is the entity which is responsible to carry out this reaction. This is the whole thing which is required. So we need this. So these to be used in more amount. These to be used in major amount, and major amount means concentrated should be used. If we are going to use concentrated, that is more amount of this is going to proceed the reaction. Now see kids, what question was asked in NEET 2016? That is the most important question. Just see. Without this, you won't be able to solve this question. Now see everyone. Question was, if very high concentration of KHSO4 is added to the nitrating mixture, then the rate of reaction, first option, then the rate of reaction A will get doubled. Second option will increase multiple time. C will decrease. D, no effect on the rate. No effect on rate. So what's your answer, kids? I'm waiting for your answer. Do let me know what should be your answer. Yes. Yes, everyone, do let me know. Let me check it out. What's your answer? With how much dedication you have gone through with this mechanism, whether you are able to solve this question or not. So, what's your answer? Everyone, do let me know what's your answer. What answer you're going to get? Do let me know, kids. Fast, fast. I want to see. I want to see your answer. Hey, everyone. I'm waiting for your answer. I'm waiting for your answer. C. Ramesh is saying C. So, kids, I'm glad to see that the first answer and the second answer, Arthi is also going for C. Kids, really, I'm feeling accomplished because of your stupendous performance. Fantastic performance, fantastic answer. I don't know how to say thanks. Really, kids, you made my day by giving the correct answer. That's really awesome. Now, see, the nitrating mixture was this. Now, if you are adding KHSO4 to this nitrating mixture, if you are adding KHSO4, that means KHSO4 is having ionic bond, and this will break into K positive and HSO4 negative. So KHSO4 negative just means that you have added HSO4 negative, and HSO4 negative was on the product side. If this HSO4 has been added, Lee Chatterley's principle says that if you are adding HSO4 negative, so this will go in the backward direction and it will take away all these things. It will not go alone. It is saying that I will take each and every one and then I will go back. I will move back. I will move back by taking off all these things, and then equilibrium will shift in the more in the backward direction. Equilibrium will go more in the backward direction. Because of this, the equilibrium will go more in the backward direction, and this NO2's concentration will decrease. And if NO2 plus concentration is decreasing, then the rate of reaction will get decreased. Everyone is able to understand? Everyone is able to understand? Fantastic. Now, Let's see sulfonation. We are going to reach for sulfonation. Everyone ready? Is everyone ready for the sulfonation, kids? Do let me know. And this explanation, you liked it or not? If yes, then show me in the chat section that yes, you are able to understand with green hearts. Green heart means that yes, you are able to understand. Now I'm going to towards sulfonation. Sulfonation. Let me write down sulfonation once again. Sulfonation. Which nation? Sulfonation. Sulfonation. We are going to deal with sulfonation. 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 Now let's see what happens in sulfonation. Definitely benzene will be there. Wow, that's really awesome that I can see everyone is able to understand. Benzene will be there. Now, the reaction of benzene should be carried out with concentrated H2SO4. Concentrated H2SO4. And concentrated H2SO4 must be taken 2 moles, means 2 moles. Why 2 moles? What's the reason? I will let you know. Now, one more thing. This reaction is being reversible. This reaction is being reversible. So, I will put this sign. I will put this sign because this is being reversible reaction. I have already told you that sulfur and carbon size difference. And then we will get SO3H, benzene sulfonic acid plus H2SO4. Now see, everyone will ask question that sir, you are using H2SO4 and H2SO4 is eliminated out also. So whenever something is used and it is getting eliminated out in the product side also, that means 1 mole is reacting as a reactant and another mole of H2SO4 is acting as catalyst. Why we have used 2 moles? That means 1 mole is acting as 1 mole of H2SO4 is acting as a reactant and another mole is acting as catalyst. Now this we will come to know in the mechanism. One more thing. Better than concentrated H2SO4 is oleum. We can use oleum. Oleum is better than H2SO4. Oleum is better than H2SO4. So if examiner is asking who is better sulfonating agent, oleum is better sulfonating agent and the name of the product is benzene sulfonic acid. Benzene sulfonic acid. Now kids, let's see each and everything, the whole mechanism of sulfonation. But before that, do you know what is oleum? What is oleum? Could you please let me know what is oleum? What is this oleum? Oleum is being liquid, solid or gas. What is being oleum? Anyone? Now if I am going to ask what is oleum, students, they start telling me oleum's formula. Oleum's formula. What is the formula of oleum? You will let me know that H2S2O7. Now, sometimes you remember it, sometimes you forget. So let me tell you what is actually the oleum is. In that way, you will never forget oleum. See kids, if I say there is water, blue, 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 blue. This is being water. How much water? Let me tell you. Let us suppose water is being 2 moles of water is there. 2 moles. 2 moles water is there. Now, to this water, SO3 once entered. SO3 gas. SO3 is saying, oh, let me take bath in this water. Let me take some bath. Now see, this SO3 is oxide of non-metal. This is being oxide of non-metal, oxide of non-metal, and non-metal oxides are known as acids. So this is being acidic. Now, water says I'm being amphoteric. Somebody is acidic in front of me, I will behave as a base. So this water is saying I will act as a base, and this acid and base reaction will take place. But see, everyone see to it. What I said, SO3 is suppose 1 mole. 1 mole. If I have taken 1 mole of SO3 and 2 moles of water, 2 moles of water, who is being accessed? Do let me know. This one I have taken 1 mole, 1 mole, and that I have taken 2 moles. Who is access? Who is in access? Kids, do let me know. So definitely this water is in access. Water is in access, and the one who is access will left behind, and this is your limiting reagent. This is going to be your limiting reagent. Everyone agreed? This is going to be a limiting reagent, and the product is decided by limiting reagent. This is 1 mole. So this will get consumed and it will react with water. Now see, SO3 plus H2O. What I am going to get? H2SO4. H2SO4. I have got H2SO4, and you know that H2SO4 is being liquid. So what is left behind? Along with H2SO4, what is left behind? Nothing is left behind. H2SO4 and water is there. That means we have got aqueous H2SO4. In this way, we have got aqueous H2SO4. Aqueous H2SO4. We haven't got oleum. This is the case number 1, kids. This is case number 1. If I take case number 2, if I take case number 2, 1 mole of water, 1 mole of water, and 1 mole of SO3. So we will get pure H2SO4 because none of them is being limiting ingredient. So in case number 2 also I haven't got oleum. When I'm going to get oleum, kids, when I will get oleum, the case number 3, just see over here, case number 3. If I talk about case number 3, everyone see to it. Case number 3. If I take SO3 in excess, let us say 2 moles, and water is the limiting reagent, what is going to happen? This is the limiting reagent. This will get consumed. H2SO4 liquid will be formed, and SO3 gas will be there. So this is being oleum, kids. Now are you able to understand? H2SO4 liquid and SO3 gas. This is being oleum. Oleum is, see everyone, what is oleum? If I say I've taken excess of water or excess of SO3. So let us suppose if I have taken 1 mole H2O and 2 moles of SO3, 2 moles of SO3. So what you are going to get? They will combine and they will form 1 mole of H2SO4. They are going to form 1 mole H2SO4, and H2SO4 is being liquid, plus 1 mole of SO3 gas will be there. 1 mole SO3 gas will be there, and that's why it is just like cold drink. Just like it is cold drink. You know, in cold drink there is carbon dioxide, and that is known as fuming H2SO4. Just combine, see, H2SO4, SO3, this is being oleum. If you combine it, just try to understand. That's why cramming is not going to help you. If you combine it, you will get H2, S2O7. This is being oleum, and that's why the name of oleum is being fuming H2SO4. Fuming H2SO4. Fuming H2SO4. This is also known as pyrosulfuric acid. Why it is known as pyrosulfuric acid? H2S2O7, because you can draw it like this: S double bond O, double bond O, OH, O, S double bond O, double bond O, OH. In P block, you will see H2, S2. How many oxygen? 3, and 3, 6. And this is one extra. So let me rub it. So H2S2O7. You can see H2S2O7. 1, 2, 3, 4, 5, 6, 7. So this is also known as H2S2O7 is also known as pyrosulfuric acid. Pyrosulfuric acid. Now kids, these are the names for oleum. So why oleum is more effective? Question arises, why oleum is being more effective? Now see why oleum is being more effective. You know, if you are having if somebody is burned with water, hot water, and somebody is burned with steam, who is going to get more burnt? Steam is more effective. So remember that your oleum is this H2SO4 liquid, this H2SO4 liquid, and in this H2SO4 liquid there is SO3 in gaseous form. This SO3 is in gaseous form. SO3 in gaseous form. So this is your oleum, and because of gaseous form, free SO3, because of this free SO3, because of free SO3, oleum is better sulfonating agent. Oleum is better sulfonating agent. Sulfonating agent. Everyone, are you able to understand what is oleum and why oleum is better sulfonating agent? Everyone, H2S2O7. If you combine H2SO4 and SO3, you will get H2S2O7. H2S2O7. Kids, today you are able to understand each and everything about H2O7. Is this requiring cramming, or it's this the physical chemistry part and the understanding part? If you liked it, at least show me the thumbs up, kids. This is only the medium in between me and you. You can show me the thumbs up, and if you are new, at least you can smash the like button, hit the like buttons. Everyone, let me see, is there anyone going to increase the likes? Let us make it up to 7. Now see how the reaction is going to take place. Now see the mechanism of this reaction. Now 1 mole of H2SO4, 1 mole of H2SO4 will donate proton. Once it has donated proton, kids, no one else is there to accept its proton. Who is going to accept proton? When there is no one, when you're just sitting in your home and there is no one to listen, you start talking to yourself. What should I do? Oh, I should do like this. Should I study or not? Or should I sleep? No. Right now, not to sleep. Too much homework is left. So, you are only talking, you are only listening. So, here H2SO4 is the one who has left proton, so acting as an acid. Now, there is no one else to accept its proton. The same H2SO4 will absorb its proton. See, he is the donor, he is the acceptor. Though 1 mole is acting as acid, another mole is acting as a base, and this is going to absorb the proton given by the first one, and this will get changed into, see what it is going to get changed. Now see everyone, it will change into HSO3 O positive H2. Now you know what dialogue oxygen will put. Oxygen will say, oh, I'm being highly electronegative. I can't tolerate this positive charge. I can't tolerate this positive charge. Oxygen will say, I can't tolerate this positive charge. Now, what will happen if oxygen is not going to tolerate this positive charge? We will say, okay, dear, no worries. We have to eliminate out water. Don't worry, we will eliminate out water. Now, once the water has been eliminated out, you will get like this. Now, this sulfur is saying, I can't tolerate this positive charge. Okay, do not tolerate this positive charge. Let's see what is going to happen. Water will come once again, and water will say, don't worry, I will take your proton. So no need to worry, you remain like this, and I will be like this. So happy ending. Let's come to the conclusion. What conclusion we are going to get? What is left behind? See everyone, this H plus will cancelled out with this H plus. This will get cancelled out with this. This H2O will get cancelled out with this. This HSO3 plus will get cancelled out with this. So they got cancelled out. What is left behind, kids? Do let me know what is left behind. One H2SO4, second H2SO4. One is acting as an acid, one is acting as a base. Can you see everyone? Do let me know that. Yes, we can see one H2SO4 is acting as an acid. One H2SO4 is acting as a base, as an acid. You are only the acid, you are only the base. You are the donor, you are the acceptor. Now anything is left? Nothing is left. Now the reaction is like this. So on the product side, we have got HSO4 negative, plus what else? We have got SO3, and we have got H3O plus. So in this way, reaction will take place. Now see, in these many steps, you have got SO3. If you are using H2SO4, these many steps are required to produce SO3 gas. If you are going to use oleum, already the oleum, in oleum SO3 is already present in the free form. That's why oleum is better sulfonating agent than H2SO4. Are you able to understand? If you are going to use H2SO4, these many steps will be required to produce SO3. Okay, thank you, Gopika Sri. I will definitely wish him. Definitely I will wish him. Thank you, Gopika Sri. Thank you. Now kids, you like this mechanism? This is known as partial differentiation method or partial balancing method to balance the reaction. In this way, sulfonation is carried out. Now, the most important thing up after sulfonation. But if I move ahead, the sulfonation, let me tell you one very, very important question about sulfonation. See, it's really very simple, but most of you will get failed. See everyone, find out the product. This is the question, find out the product. Will you try? It's very simple question, but maximum of you will get failed. Question is, find out the product. Find out product. So the question is, this is benzene sulfonic acid, SO3H. Either they will give you product or they can give you name. Name is benzene sulfonic acid. Benzene sulfonic acid. Now, this benzene sulfonic acid has been treated with dilute H2SO4. Dilute H2SO4. I am not going to give you the options. Now let me know what product will you get. What should be the product? Kids, do let me know. This is the question. This is the question, and I am asking for the product. Do let me know what product you are going to get. It's simple question, and definitely I taught you. Yeah, I have taught you. Once I'm going to tell you the product, you will come to know that yes sir, you have already explained it. Now it's our time to give the answer, but you won't be able to give the correct answer. And see, this is when I'm going to explain it, then you will come to know that yes sir, whatever you said, it's really working. Hey everyone, I'm waiting for your answer. I'm waiting for your answer. Kids, do let me know. Everyone. No, no one? Sir, wait, sir. We are going to give the answer. Just wait for a second. Give us some time, sir. Don't do that. We need some time. We are small kids. Everyone, likes still only 67. At least make likes up to, they should reach up to 70. Let them see how 70 looks like. Now, kids, you're not able to give the answer. Let me tell you, the answer will be benzene. Benzene will be answer. Now you will ask, sir, how? Definitely you will ask how. Definitely you are going to ask how. Should I explain? Should I explain? Just see. What reaction I have taught you right now? I have taught you this reaction that benzene plus concentrated H2SO4, what product will you get? We will get, so benzene sulfonic acid plus H2SO4 plus water. So H2SO4 plus water, can I call it to be dilute H2SO4, kids? Can I call it to be dilute H2SO4? Dilute H2SO4, can I call it? So this reaction was reversible. I've told you this reaction is reversible. What I did, I've just kept these product side over here. Just see benzene sulfonic acid plus dilute H2SO4, benzene sulfonic acid plus dilute H2SO4, and the reaction will come in the backward direction. So we'll get benzene plus H2SO4. So this reaction, I've told you or not, this is just the way of thinking. We always think like that. Whenever the reaction which is given as reversible reaction, we always got the habit of moving in the forward direction. We cannot see that the reaction simultaneously is coming in the backward direction, and the backward direction, for the backward direction reaction, this is going to be the reactant, and for the forward direction, this is going to be the reactant. Both are being the reactant. Just we have to see that from which side to which side we are moving. If we are moving in the backward direction, this is going to be a reactant. If we are moving in the forward direction, this is going to be a reactant. Everyone is able to understand. So this is known as sulfonation. In the forward direction, this is known as sulfonation. In the backward direction, simultaneously, it is known as desulfonation. Desulfonation. Everyone agreed? If you are able to understand, show me the thumbs up. Everyone, kids, if you got it, show me the thumbs up that yes sir, we got it. And this was really awesome question. So everyone was supposed to give the correct answer, but this really happens with each and everyone. We are often going to miss it. Now we are going towards, we have done halogenation, we have done nitration, we have done sulfonation. Now we are moving towards Friedel-Crafts alkylation, and number of questions will come from Friedel-Crafts alkylation. Everyone ready? How's the Josh? We are going to move towards Friedel-Crafts alkylation, the very important reaction. Friedel-Crafts alkylation, fantastic reaction. Friedel-Crafts alkylation. Very important. Number of questions will come based on Friedel-Crafts. Now I am rubbing it. Do let me know what I have written over here. Everyone, do let me know what I have written over here. Just do let me know what I have written. Friedel-Crafts alkylation. Friedel-Crafts alkylation. Now see, Friedel-Crafts alkylation. Looking good? Looking good? Friedel-Crafts alkylation looking good or not? Because this is very, very important. So I have written in the proper font. Proper font I have used for Friedel-Crafts alkylation because this is really very, very important reaction, and that's why I've used proper fonts for it. Friedel-Crafts alkylation, because this reaction is very, very important reaction. See kids, everyone, Friedel is the name of scientist. Friedel-Crafts alkylation. Now see what is going to happen over here. Simply, I would like to say that this reaction will proceed like this. Everyone see to it. This reaction will proceed like this. There is benzene, and benzene will react with RCl or whatever X. This X can be either chloride, bromide or iodide, but it can't be fluoride because fluorine's bond is very, very strong bond, and we will use anhydrous AlCl3 or any Lewis acid like anhydrous AlCl3. Now we will get alkyl benzene. We will get alkyl benzene plus HCl, HX, and plus Lewis acid. Now this reaction is looking like very, very simple reaction. Everyone who is studying in class 11th or 12th, they must have studied this reaction. This reaction is looking very simple, but it's not simple reaction, kids. Let me tell you, if you are just going to write for your school, you can write it like this: CH3, Cl, and you can show the representation also. Although that representation is not correct, but for a school level, you can do happily that thing, that you can take H and can remove H delta positive, Cl delta negative, and this can be removed like this. Ding 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 ding. Now, what you are going to add? The product toluene, ma'am. Toluene is the product. The product is being toluene. But for school level, it will work. For your school level, it is going to work, but not for your NEET examination. Why for the NEET examination it is not going to work? Let me tell you. Let me explain. See, for your competition level, you are going to use this benzene. You have used methyl chloride, suppose. Now methyl chloride you have used, anhydrous AlCl3 you have used. You got toluene as earlier. Now this methyls hydrogens will show plus hyperconjugation and plus I. Due to plus H and plus I, this is ortho para-diacting group. Negative charge over here, negative charge over here, negative charge over here. So this is being, toluene is being ortho para-diacting group. CS3 is being ortho para-diacting group. So once again its alkylation will take place. Once again it is going to react with methyl chloride, and you will get two types of more products. Two more types of products. What are they? This was toluene, one methyl at this place plus one methyl at this place. So total you have got how many types of products? Because this is being organic reaction, will never complete. So you got one type of product, two types of product, three types of products. So this is known as xylene. When on one benzene there are being two methyl groups, this is known as xylene, and this position is known as ortho, OMP, ortho meta para. So this is being ortho para meta, ortho meta para. So this is being orthoxylene, and the name of that product is being paraxylene. So you have got mixture of products. As the mixture of products are being obtained so this process is not good process. So this is an inferior process, not a good process, not a good method for alkyl benzene preparation. For alkyl benzene preparation, it's not a better way, it is an inferior method. Now see kids, okay, it's inferior, doesn't matter. Let's see what questions can be asked based on this. See everyone. The simple reaction I have given to you, that this is your benzene and its hydrogen has been replaced. By this methyl chloride. Although this is not the correct approach, we are going like this. I will let you know the mechanism, but for a while we can consider it like this, that this reaction has taken place, H positive Cl negative, and it has given one product like this. This is your being toluene. Now, if in the question they have given you like this, see everyone, if they are going to give you that 2 moles of benzene, if 2 moles of benzene has been used and they are using dichloromethane like CH2, Cl2, this is known as dichloromethane or methylene dichloride. Just remember the name, methylene dichloride. Everyone just try to understand methylene dichloride or methylidine. One more name can be used, methylidine, because this is really very, very important compound, methylidine chloride. If simply they are writing chloride, then also it means methylene dichloride, or you can say dichloromethane. Any of the names can use dichloromethane. Now you can see very clearly there was just one chlorine, so once reaction took place, here are 2 chlorines. So how to do the reaction and what product you are going to get? So definitely you are going to get CH2 and 2 benzenes will be there on this carbon. See kids, 2 benzenes will be there, diphenyl methane. 2 moles of HCl will eliminate out, but the same reaction has taken place like this. See everyone, if the reaction is going to take place like this, that 3 moles of benzene, kids, just try to understand, 3 moles of benzene has been used and they are using chloroform CHCl3. In my school time, I thought it's not chloroform, I thought it's methyl chloride, but they are being different. Now, this was methyl chloride, this was just methyl chloride, but there it is being chloroform. Chloroform is having 3 chlorines. Just try to understand, they are not same, they are being different. Chloroform. Now, what should we answer? Just try to understand in your brain that carbon will be attached with 3 phenyl rings. Just try to understand, 3 phenyl rings will be there on one carbon. So this will be your answer. Now kids, the most important question after 1, 2, 3 reaction, the 4th reaction, that is going to be the game changer. See what they have asked. Once it has been asked that we are using 4 moles of benzene, once the 4 moles of benzene and they are using carbon tetrachloride CCl4, so definitely 99% students, what the answer they are going to give, they will say 1 phenyl, 2 phenyl, 3 phenyl, 4 phenyl. They will give this answer, and this answer is absolutely wrong, kids. Examiner is going to give big 0. This is being wrong answer. Why it is being wrong, kids? One carbon can accommodate maximum of 3 phenyl. carbon cannot accommodate 4 phenyls because carbon is being small. Maximum phenyl rings accommodated by carbon, they are how many? They are just 3 phenyl rings. So the correct answer is this carbon, this phenyl. Let me write down properly so that you can visualize it also. This is one carbon, this is one phenyl ring, kids. One phenyl like this, you can see this is one phenyl ring, this is being the third phenyl ring. You can see there is no space to accommodate the fourth phenyl ring. So this is your answer, this is the correct answer, this will be your answer. Everyone able to understand? So take care of this product. This product is really the most important one. Now let's deal with the mechanism of this reaction, and number of questions will come in your examination based on this. So are you ready? Everyone ready? Now see, once we are going to deal with this question, that how the reaction is going to proceed. This is your benzene, and once the benzene is treated with Rx, let us suppose Cl, so this is going to react with anhydrous AlCl3. Anhydrous AlCl3, this aluminium is having just 6 electrons in the valence shell and it is in need of electrons. So it is in need of electron. This will come over here and will snatch the electron of chlorine, as well as chlorine will go along with AlCl3. Actually, AlCl3 is just in need of electrons. AlCl3 is not going to love chlorine atom. It's not interested in atom. It is just interested in electron. But chlorine is saying, I will come along with you. Now you see what thing will get produced over here. You will get this R positive as carbocation. You can see very clearly R positive as carbocation. And this is the most important thing. This is going to be the game changer, that carbocation has been produced. Whenever carbocation is going to get produced, this is being an intermediate. This is being your an intermediate, and the rate of reaction. First thing is that rate of reaction is directly proportional to stability of intermediate, and whenever the intermediate is formed, always think about rearrangement. Always think about rearrangement. Think about rearrangement. Very, very important point, kids. Always think about what? Rearrangement. I'm not saying always do rearrangement. Think about rearrangement. Whenever the carbocation is formed, always think about rearrangement. If you're not thinking about rearrangement, you are doing something wrong. And if the rearrangement is going to produce stability, then rearrangement will definitely take place. What are the type of rearrangements? Hydride shift, 1 to hydride shift, 1 to methyl shift, and ring expansion. These are the type of rearrangement I must have told you a number of times. Now see kids, let me give you one question based on it. See, this is the most frequently asked question. Most frequently asked question, that benzene has been allowed to react with N-propyl chloride. CH3, CH2, CH2, Cl. This is being N-propyl chloride. N-propyl chloride. Now, what will be the product? Now, straight away, if you are going to write product, so this is the product. If you're writing like this is the product. Then examiner is going to give you big 0 because you have written directly the product without mechanism. This is your minor one. This is not major, minor product. So who is going to be the major product? See kids, once your anhydrous AlCl3 is going to snatch electron from here, this carbocation is going to produced. Once this carbocation has been produced, CH3, CH2, CH2 positive, So this is being carbocation and you're supposed to think about rearrangement. So what type of rearrangement can take place? From here, one H negative will shift. How the H negative will shift? Let me tell you, let me explain. CH3, CH, one hydrogen, one more hydrogen, CH2, plus this is having 6 electrons, and adjacent to it there are 2 alpha hydrogen atoms. So this is stabilized, this carbocation is stabilized by hyperconjugation just with 2 alpha hydrogen atoms, and this is stabilized by inductive effect, that is being 1 degree carbocation. But if this hydride is going to shift by taking electron, this hydrogen is moving towards this. Now, which carbocation you are going to get? You will get carbocation like this, CH3, CH plus CH3. Now this carbocation, you can just imagine that 3 alpha hydrogen, 3 alpha hydrogen, 3 plus 3, that is being 6 alpha hydrogen atoms. So it is being stabilized by 6 alpha hydrogen atoms. And if I talk about is stabilized by inductive effect, this is 2 degree carbocation. So in all respect, that Y carbocation is being more stable. Are you getting my point? This Y carbocation is more stable. More stable means more formed and more responsible for product formation. Let me tell you, more stable carbocation means more formed. This name is isopropyl carbocation. Its name is being isopropyl carbocation. Isopropyl carbocation. So isopropyl carbocation is being more stable, so more formed, more stable carbocation, more formed and more formed, so more responsible for product formation, more responsible for product formation, right? So what product you are going to get in major amount? This carbocation will attack on benzene. This carbocation is going to attack on benzene. So the major product will be like this, CH, CH3, CH3, and you should know its journal name, because journal name of this compound is really very important. What's that? The journal name is cumene. Just remember cumene. Why you are so mean? Cumene. The journal name is cumene. This is really very important. Cumene. Why you are so mean? Cumene. And its proper name is isopropyl benzene or isopropyl benzene. Isopropyl benzene to everyone can write, but cumene is little bit tougher. So just remember this cumene, the examiner is interested in cumene. So everyone, if you got this answer, now one question for you people, if you are able to understand, do let me know the product of this reaction. Everyone ready? I hope that no one got tired. So this is the question, kids, in front of you. If examiner is giving you a question like this, CH3, CH, CH3, CH2, Cl, anhydrous aluminum chloride, anhydrous aluminum chloride. What is the product? Everyone, do let me know what should be the product. I am waiting for answer. Now see, let me solve it, then you can solve the another one. This anhydrous AlCl3 will take away the chloride of this carbon will develop positive charge. Once the positive charge has been developed, you can see what carbocation you are going to get. You will get CH3, CH, CH3, CH2 plus. Now you can see very clearly adjacent to it there is just one carbon attached. This is being alpha carbon. This alpha carbon is attached with one alpha hydrogen, so it is stabilized by hyperconjugation, but just one alpha hydrogen atom, and it is stabilized by inductive effect. It is 1 degree. Now, if this hydride is going to get shifted, if this hydride by taking its electron is going to get shifted over here, what type of carbocation you are going to get? This reaction is always being reversible. The more stable carbocation will get more formed and more responsible for product formation. So you can see the carbocation, this carbocation CH3, C plus, CH3 and CH3, this is stabilized by hyperconjugation. And how many alpha hydrogens are present? Just see, 3, 3, 3, 9 alpha hydrogen. Oh my god, there was just one, and stabilized by inductive effect. This carbon is attached with 1 carbon, 2 carbon, 3 carbons, so 3 degree. This is more stable, so more responsible for product formation. So what answer you are going to get, kids? The question's answer will be tertiary butyl benzene. Tertiary butyl benzene. This will be the answer. Everyone is able to understand third, that is tertiary butyl benzene. Tertiary butyl benzene will be the product. I hope that everyone is able to understand. Now, let me tell you in how many ways cumene can be prepared, because the worldwide production of phenol is done from cumene. So cumene has become very important, the first choice of examiner. So everyone, I think that everyone is able to understand. You people are not getting tired, because we have started at 10 and it's going to be 12:38. Kids, just to let me know that we should continue like this. Are you having enough energy? Aspiring medico, Devojit, wow, Ramesh. Kids, are you liking it? Everyone, are you enjoying it? Do let me know that everyone is enjoying it. Let me move ahead. See, in how many ways that cumene can be prepared? See, this is your cumene. This is being your cumene. This is being your cumene. And I will let you know why cumene is that much important. Why cumene is that much important. The first way, I've already told you that if you react your benzene with, N-propyl chloride, this mechanism already have explained. N-propyl chloride, that is CH3, CH2, CH2, Cl, and anhydrous AlCl3, right? This already I have told you. Now, the same cumene can also be prepared by, if you use isopropyl chloride. If you use isopropyl chloride, directly you will get cumene without rearrangement, right? So these two methods you can understand clearly. You can answer it. But if I say the same cumene will get produced if you use propene and acidic medium. Propene, acidic medium. Now I will say, sir, how we are going to get cumene from this method? Please explain. I will explain it. Now I will say, even you will get cumene if you react this with N-propyl alcohol, CH3, CH2, CH2, OH. All are these questions which have been asked. All these questions have been asked, my kids. Now you will get same cumene if you react this benzene with isopropyl alcohol, CH3, CHOH, CH3, acidic medium. Now definitely in your brain it must be coming. So these two we are able to understand, but how these three we are going to get cumene? By these three, how we are going to get cumene? before I explain that how you are going to get cumene by these three processes, let me complete this chart because this is going to be very, very important. If you react this compound with oxygen, that is air, excess of air, that is oxygen, let me tell you, this hydrogen is benzylic hydrogen, loosely bonded. This is being alpha hydrogen, you can say benzylic hydrogen, you can say number of names are there. Alpha hydrogen, two alpha, no, it's one alpha hydrogen. Alpha hydrogen atom is there. Alpha hydrogen atom. Now, this is weakly bonded, weak bond, weak bond. Now, you know, whatever the position is being weak, if air is supplied, air will react with that. Now, once the air is going to be in its contact, that will get oxidized. See how it is going to get oxidized. This CH3 already here, this CH3 already present over here. This hydrogen will get replaced, and place of hydrogen, oxygen is going to take its place, and hydrogen will get shifted over here. Now see, this is having -1, this is known as peroxide. When oxygen is having -1 oxidation state, it is known as peroxide, and this compound is highly unstable. This compound is being highly unstable compound, highly unstable. This is known as cumene hydroperoxide, cumene hydroperoxide. Number of examinations, hydroperoxide. This has been asked in number of examination every time, whether it is the paper of IIT or the paper of NEET, that this is their first choice. They are always asking this question. This is very important. Aspiring medico, thank you, thank you. So this is highly unstable. Why it is being highly unstable? Its reason is being because it is peroxide, so it is being highly unstable, highly unstable, highly unstable. Now, if this is going to come in contact with H3O plus, that is water in acidic medium, either you can write it like this or H3O plus can be written over there. Both mean same. Now, see what is going to happen. Everyone see to it. What is going to happen over here? This bond, you know, this carbon is double bonded, this single bonded, its electronegativity is 2.5, its electronegativity is 2.75. How the bond is going to break, just see over here. This is being more electronegative, so it will withdraw electron of this carbon, and this carbon is feeling positive, so negative. Now positive, negative, they will form a bond like this, and you can see this is being acetone. You can see this is being acetone, and this negative charge will combine with this positive charge to form phenol. So phenol, worldwide production of phenol is done by this process, and acetone over here is the side product. Acetone is the side product. It is given in NCERT class 12. Worldwide production of phenol. Phenol's worldwide production, kids. Are you able to understand phenol's worldwide production? Worldwide production. This is the side product. Side product. Acetone is the side product. Side product. That's why your cumene is very, very important reactant. This cumene is very, very important reaction because worldwide production of phenol is done by this method, and phenol is really the very, very important thing, and that's why this cumene has become examiner's first choice, examiner's first choice, and this is the reason, kids. If you are able to understand, please show me the thumbs up, and at least smash the like buttons, hit the like buttons. I want to see likes to get increased. They should reach up to 80. Our target is just to make them century, right? Now, I was about to tell you the mechanism for these three things, how we have got cumene from this. So see, everyone see to it. If I'm using propene, CH3, CH double bond CH2, and I have added acidic medium. Acidic medium has been provided, that means some acid. let us suppose H plus. Now this H plus will go and attack over here. It's going to attack. You will get CH3, CH plus, CH3. You can see isopropyl carbocation. You have obtained isopropyl carbocation. Isopropyl carbocation has been obtained, right? Now everyone see, if I am going to use propyl alcohol CH3, CH2, CH2OH and propyl alcohol. Now I have added H plus, or somebody has added H plus. This H plus is in search of lone pair. This will attack over here, and what you are going to get? You will get oxonium ion. What you are going to get? Oxonium ion. CH3, CH2, CH2, O positive H2. This is known as oxonium ion because oxygen has lost one electron, so the plus charge has been developed on oxygen. So once we have got oxonium ion, oxygen will say, I can't tolerate this positive charge. Then we will also say, okay, let's remove water from it. Once the water has been lost, once the water has been lost, we will get carbocation like this, CH3, CH2, CH2 positive. Now 1,2 hydride shift will take place. 1,2 hydride shift will take place. So what you are going to get? 1,2 hydride shift. Once the 1,2 hydride shift has taken place, you will get most stable carbocation CH3, CH plus, CH3. This is going to attack over there. Now kids, everyone, are you able to understand why in all the cases we have got cumene as the product? Now, intramolecular Friedel-Crafts reaction. See, just apply your brain whether you are able to understand this intramolecular Friedel-Crafts alkylation or not. Okay, everyone. Intramolecular Friedel-Crafts alkylation. Let's see computer, what computer is going to write, whether computer is writing completely correct or incorrect. Wow. Intramolecular, what I have written, computer has given to every action there is equal and opposite reaction. Intramolecular Friedel-Crafts alkylation, right? Now see, everyone see to it. If I write like this, CH2, 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 Cl, anhydrous aluminum chloride, anhydrous AlCl3. What do you think how the reaction will take place? Everyone do let me know. What do you think how the reaction is going to take place? Let me check it out how the reaction is going to take place. So I think you must have thought in your brain that first of all, this AlCl3 is going to snatch electron of this chlorine. Have you thought like this? If yes, then yes, definitely you are on the right path. You are on the right path. Now, this compound is having 2 alpha hydrogen atoms, so definitely this is ortho and para diacting group. Always remember that whenever the ring of 6-membered or 5-membered or 7-membered is formed, these rings are highly stable. So you see, this plus charge carbocation formed will attack on this carbon, So after attacking, see what you are going to get. We will get something like this. This CH2, this CH2, one more CH2, and this is the new bond form, So you can see one ring is 6-membered and another ring is 5-membered ring. You can see this is being 5-membered ring. Can you see very clearly 6-membered and 5-membered ring? So this is your final product. I hope that everyone is able to understand that this is your product. Now, so Friedel-Crafts alkylation is very much clear to all of you. Now I'm going to move towards Friedel-Crafts acylation, and Friedel-Crafts acylation is a superior method as compared to alkylation. Now is everyone ready to understand why the Friedel-Crafts acylation is superior method and what will happen in Friedel-Crafts acylation? That everyone ready? Show me the thumbs up, because really I appreciate a lot for your efforts, for your perseverance, for your persistence, for your continuity, and definitely for each and everything. Really good, really good. Sir, will the attack be direct? Yeah, direct, intramolecular. That's why it is known as intramolecular. Within the reaction, this attack is taking place, and that's why it is being direct. That's really awesome. So nice of you kids. Now we are going to move towards Friedel-Crafts acylation reaction. Friedel-Crafts acylation reaction. Friedel-Crafts acylation. Now see, in this Friedel-Crafts acylation, rearrangement does not take place. Rearrangement, no rearrangement reaction, no rearrangement, no rearrangement reaction, no rearrangement. 1 point, no rearrangement. First point, no rearrangement. Second point, pure product is formed. Pure product is formed. Wow, pure product is getting formed. That's really awesome. Pure product formation. So this method is said to be superior to alkylation. That's why this method is known as superior than alkylation. Superior than alkylation. Superior than alkylation. It's superior than alkylation. Now, number of things are there. Let's see why we are writing this and what things are responsible for this and what's the mechanism behind it. Why no rearrangement, pure product formation, and one more thing, the very, very important thing, no further acylation. No further acylation. No further acylation. These are the points which are really very, very important for Friedel-Crafts acylation. No rearrangement, pure product formation, superior method, no further acylation. So answers to each and every questions we will get from the mechanism. Mechanism is the most important thing which is going to give the answer of each and everything. So let's see what is Friedel-Crafts acylation, why these things are like this. Now everyone, if I say this is your benzene and this benzene has been allowed to react with R C double bond O X, acid halide. This is known as acid halide. Okay, this is being acid halide. Now we are going to use some catalyst, Lewis acid. Definitely Lewis acid we are going to use, like anhydrous AlCl3. Now this anhydrous AlCl3 is just having 6 electrons, so it is in need of electron. It will take this X negative, and this carbon will develop positive charge. Once the carbon has developed positive charge, you will get only one product. You are going to get only one product, COR. Now you will say, sir, why no other product is going to get formed? Let me tell you, let me explain. This carbocation you have obtained this carbocation RCO positive, right? Now just think, this RCO positive, this carbon is having 6 electrons, only 6 electrons, and this oxygen is having 8 electrons. But this carbon is having vacant 2p orbital, vacant, that is empty, vacant 2p orbital, 2p, and this is having lone pair in 2p. Can you consider anything that back bonding will take place, and it will stabilized by back bonding? This carbocation is going to stabilized by back bonding. Back bonding is a 2-atom resonance, so you will get RCO and one positive charge on oxygen. Now this is having 8 electrons, and this is also having 8 electrons. This is stabilized by back bonding, stabilized by back bonding. And number of time, you can say most often kids, they forget about back bonding. They are not able to keep in their brain back bonding. Back bonding is 2-atom resonance, that is 2-atom resonance, 2-atom resonance. So never forget about back bonding. And due to this stabilization, rearrangement never take place, because this carbocation is already stabilized by resonance. This carbocation is stabilized by resonance, So no need of shifting. That's why there is no need of shifting. Right? Now, once there is no need of shifting, now question arises, why further acylation is not going to take place? You can say this carbon which is directly attached to benzene is having positive charge. So it is meta directing, and once the meta directors are there, they decreases electron density on benzene. All meta directors decreases the electron density on benzene. So further acylation cannot take place. Let me write down this thing. Whenever there is any meta director like this is being meta director, what it is going to do, it will withdraw electron from the benzene by minus I as well as minus M, that you can say minus R. So it is going to withdraw electron, and it will create positive charge on orthopara. So benzene has become less electron deficient. Benzene has become less electron rich, and once the benzene has become less electron rich, so can't undergo ESR easily. That's why can't undergo ESR easily. So it can't show ESR easily. So no further acylation. So this is the pure product. Now gets question arises, we have got acyl benzene, but during Friedel-Crafts alkylation we were talking about that we are supposed to prepare alkyl benzene. How acyl benzene can be converted into alkyl benzene? Now see how conversion of acyl benzene to alkyl benzene. Conversion of acyl benzene to alkyl benzene. Now, there are three methods by which acyl benzene can be converted into alkyl benzene. Let's see what are these three methods. Very, very important methods for all type of examination, that we are supposed to convert this compound into this compound. That means in place of oxygen, we have to put two hydrogens. Then we will get alkyl benzene. This is being acyl benzene and that is being alkyl benzene. This is being acyl benzene and that is being alkyl benzene. How to convert? Most of you must know alkyl benzene. The first reaction that is known as, yes, anyone? What's that? Wolff-Kishner reduction. Have you heard this name? Wolff-Kishner reduction. Anyone? Wolff-Kishner reduction. Wolff-Kishner reduction. Wolff-Kishner reduction. Now, in Wolff-Kishner reduction, which reagent we have to take? Which reagent we have to take? That is, yes, anyone? Which reagent we have to take? NH2. NH2, that is known as hydrogen KOH, ethylene glycol, CH2OH, CH2OH. So, what is the name of NH2? NH2, Nehatu. What is the name? Name is, yes, what is the name? Name is hydrogen. What is the name of this compound? Ethylene glycol. Ethylene glycol. Now, this is one way for this reaction. If you're not liking this way, or the examiner has not given you this way, then there is another method, kids. What's that? That is known as Clemenson's reduction. What? Clemenson's reduction. Clemenson's reduction. Now, what you are supposed to use? Zinc amalgam HCl. Zinc amalgam HCl. This is the second method. If you're not liking this method also, there is the third method. The third method is HI red phosphorus. HI red phosphorus. It is not having any name. HI red phosphorus. You can use HI red phosphorus. So these are the three ways that are going to give you. Now I'm going to give you one question, kids, right? And I would like to see the answer also from your side. But quickly, don't take too much time and just try to give the answer. So examiner is asking this question from you people, that this is going to react with CH3 COCl. This is known as CH3 COCl is known as, kids, ethanoyl chloride. This is the IUPAC name, ethanoyl chloride. This is being the IUPAC name, or the journal name is acetyl chloride. Journal name is acetyl chloride. This is being journal name, acetyl chloride. Now, this has given you a product. Now, A has been treated with N2H4 KOH. Only this much is given, N2H4 KOH. And this is giving out B. Now, what is B? Examiner has asked, what is B? Kids, everyone let me know, everyone, what is being B? So, examiner's question is like this. Now, I want to see your answer in the chat section, what answer you are going to give. Fast. If you're giving the answer fast, quickly, that means that you are able to understand, otherwise not. Let's see who is going to give the first answer. So definitely this is your C6H5COCH3. Its journal name is benzyl chloride. No, go wrong answer. Wrong answer. This journal name is acetophenone. Its name is acetophenone, kids. Acetophenone. And this will react to give you ethyl benzene. So your answer is being ethyl benzene. This is the correct answer, kids. And this was easy kill question. This was easy kill question. You can give it the answer of this question easily. Toluene. No, it's not toluene. It's not toluene. See, here two hydrogens will be there. That is being methyl. It's not toluene. Everyone got failed. It is being ethyl benzene. Kids, do let me know that you are able to understand or not. It's being ethyl benzene. Kids, don't do like that. Just do let me know that yes, everyone is able to understand or not. Yes. Now, if I give you another question, see, if question is being asked like this, that this is your benzene, and this benzene has been treated with benzoyl chloride. Now kids, what is this benzoyl chloride? If you don't know the structure of benzoyl chloride, you won't be able to understand. So let me give you the structure of benzoyl chloride. C6H5COCl. This is benzoyl chloride. So it has given A. Now this A has been treated with zinc amalgam. Amalgam means Hg. Zinc amalgam HCl. So they have asked B. What is B? Everyone do let me know what's your B. So kids, this time let me check it out whether you are going to get the correct answer or not, whether you are able to find out the answer or not. And everyone, those who are new, please hit the like buttons. Our target is at least like should reach up to 100 before completing this session. Everyone, now see this A1, this Cl will eliminated out. This Cl will eliminated out. This is being negative and this is being delta positive, and this is going to attack on benzene. This will attack on benzene. So what product you are going to get, kids? You will get A like this. This is your A. This is your A. Its journal name is benzophenone. Always remember, it is known as benzo. Everyone say benzophenone. Benzophenone. Or we can say diphenyl ketone. Diphenyl ketone is simple word. Everyone can understand diphenyl ketone. That is very simple. Diphenyl ketone. So examiner used to give benzophenone. Now here that Clemenson's reduction is being taking place. Clemenson's reduction. Now Clemenson's reduction is taking place. So we will first prepare the same benzophenone, and what we are supposed to do in place of these two oxygens bond, we have to put CH2. So diphenyl methane is the answer. Diphenyl methane. Wow. R3, fantastic. Benzophenone, Madhavi, Madhu. My goodness, everyone is able to understand this is being diphenyl methane, fantastic kids, fantastic. That now I can say yes, everyone is able to understand. So let me give you intramolecular Friedel-Crafts acylation. Let me show you intramolecular Friedel-Crafts acylation. Intramolecular Friedel-Crafts acylation. Intramolecular Friedel-Crafts acylation. Friedel-Crafts acylation. Now suppose if the examiner is going to give you a question like this, CH2 CH2 COCl, and this compound has been treated with anhydrous AlCl3 to give A. Now A has been treated with HI red phosphorus to give compound B, and they have asked what is B. Let me check it out whether you are able to give the correct answer or not. Now see, everyone check it out that yes, we are also doing like this is being delta positive, this is being delta negative. So this anhydrous AlCl3 will take this chloride, and what A you are going to get, because this is alpha hydrogen, so this is being ortho and para diactor. So this delta positive will attack on this carbon. So 3 carbon of its and 2 carbons this, it is going to form 5-membered ring. See how? This to already like this, and CH2. Let me write down CH2, this CH2, this one CH2, and this C double bond O. The 5-membered ring, 3 carbon over there, and this 5-membered, it can be written like this, or it can also be written like this. Both mean same, kids. See, it can also be written like this, and double bond O. Both mean same, and this is being HI red phosphorus. So here the reaction will take place, kids, and your product will be, so this is going to be the answer. One ring of 6-membered, another ring of 5-membered. So this is your answer. Everyone agreed? Everyone agreed, and everyone is able to understand. Kids, hit the like buttons if you're liking my teaching. Please do let me know how good I'm teaching, or you can say bad. You're not able to understand, or the quality is not there. Whatever you want to say in the comment section, you can write, kids. But at least do let me know how I'm teaching. Along with hit the like buttons, at least it should go 80. At least it should go up to 80. Now let me tell you the note. Very, very important note. Very, very important note. See, what's that? Most important note for examination. Most important note. That aniline doesn't undergo FCA. What is this FCA? FCA is Friedel-Crafts alkylation. No problem, Madhavan, no problem. Only the structure is required. Their structure will be given. You can go for the structure. Best level of teaching. Thank you, aspiring medico. Thank you. FCA stands for Friedel-Crafts alkylation and Friedel-Crafts acylation. Friedel-Crafts alkylation as well as Friedel-Crafts acylation. Friedel-Crafts alkylation as well as acylation. This thing you will get in aniline chapter, page number 394, class 12th in old NCERT, and 404 in new NCERT you will get in NCERT. Now see why aniline does not undergo Friedel-Crafts alkylation or Friedel-Crafts acylation. See, let me tell you the reason. It's not the cramming part. Reason is there. See, if you are going to deal with Friedel-Crafts alkylation of aniline, first let me tell you, this is aniline. If I divide aniline, this NH2 is saying I'm being basic. This is NH2 because it is having lone pair, so this is being basic, and it is attracting, this basic part is attracting the acids, will attract acids, because base likes acids, will attract acid. Now this is benzene, and benzene is being nucleophilic. This benzene is being nucleophilic. So nucleophile will attract what? Nucleophile will definitely attract electrophile. Will attract electrophile. Now, by chance, the one who is being attracted is having both the phenomena, that is being acid as well as electrophile. So which reaction is fastest? Always remember, when both the possibilities are there, do remember, when both the possibilities are there, what are these two possibilities? That is acid base neutralization as well as electrophilic nucleophilic reaction. Then always give preference to acid base neutralization, ABN. ABN is acid base neutralization. Why? This is being fast reaction. Acid base neutralization will always give preference because this is being fast reaction. Being fast reaction, always get preference. Being fast reaction. So always this should be given preference. This should be preferred. Preferred. Always to remember, without any exception, we have to go for this. Now see, an aniline, what is going to happen? Everyone see to it. This is your aniline. And if you are going to react this aniline with CH3COCl, that is Friedel-Crafts acylation, and A anhydrous AlCl3. Now anhydrous AlCl3 is electron deficient, only 6 electrons, the Lewis acid. Now this Lewis acid will say, why should I attack on this sigma bond when I'm having lone pair? Lone pair can be easily attacked. So it is just like you are provided with pizza and chapati, 3 days back chapatis. So definitely you are going to eat pizza, right? Or the fresh chapati, or 3 days back earlier somebody made those chapatis. So the fresh one you are going to eat. So this AlCl3 will say, I will attack on this lone pair, So see, this is being base, and that is being Lewis acid. So acid base neutralization will take place. This is being acid. So acid base neutralization will take place, and what you are going to get? You will get compound like this. This is benzene, and nitrogen will lose its electrons, so it will form positive charge, and AlCl3 being negative. Now this is salt, and salts do not participate. Salt formation has taken place. Salt formation has taken place. So this salt formation has taken place, and this nitrogen positive will try to withdraw electron from this benzene, and benzene has become less electron rich, and less electron rich is not going to react. So benzene has become less electron rich. No further reaction. One more point is there that all meta-diacting groups, they will also not show Friedel-Crafts alkylation as well as acylation. Just like aniline is not going to show Friedel-Crafts alkylation as well as acylation, meta-diactors will not show. Meta-diactors will also not show. All meta-diactors, this is also second point, all meta-diactors will not show FCA, Friedel-Crafts alkylation as well as acylation. Why? because all method actors, because all method actors make benzene less electron rich, so no further alkylation or acylation. Sir, what class will be next and when? Kids, next class I will start based on your the best part, that is being substitution. Alkyl halide class 12th chapter, we will proceed towards class 12th chapter. That is, we will cover over there SN1, SN2, E1, E2, a very big chapter, and the most fantabulous reactions. They are the most, you can say, it holds a hell lot of weightage for your NEET examination as well as for IIT also. Now kids, this is all about this chapter. Now let me tell you what are meta-directing groups. Okay, Ramesh, let me tell you meta-directing groups. So see, what are meta-directors? If I say when benzene is attached to any group like this, electron deficient, this compound is being electron deficient, or you can say if this compound is attached with 3 halogens, this is also electron deficient, or it is attached to compound like this is also electron deficient. Now you will say, sir, how to determine that all these compounds are electron deficient? Now see, this too we can completely say that this is having positive charge, so it is minus I and minus M. It is going to withdraw electron from benzene and it will take benzene's electron and will put positive charge. Now this compound is not looking like that, but see, this chlorine's electronegativity is 3.5 and this is just 2.5. So it is actually like this, negative and positive, negative and positive, negative and positive. So once again, it is going to withdraw electron from benzene, and this is known as minus I and minus H. Minus H means reverse hyperconjugation. Just to see this reverse hyperconjugation, you have to see GOC lecture. I've told you all these things in GOC 2. Now see, it is oxygen's electronegativity is 3.5. This is just 2.75. So this is negative and this is being positive. Once again, it is going to put positive charge, positive charge. So once again, it is being minus M, or we can say minus R. All of these are being meta directors. Even I can say nitrobenzene, that is being meta director, because nitrobenzene you can see like this oxygen. So the oxygen is being more electronegative. It is going to negative, it is going to be positive, so it will take electron from benzene, etc. Everyone is able to understand this? I've told you, taught you in GOC part 2. Everyone is able to understand. Is it clear to each and everyone? I hope that. Now let me give you one question for your homework. You just try to find out the answer of that question, and that is really going to be the awesome question, right? So first question is, two questions I am going to give you. Question number 1, which will decolorize bromine water, Br2 water? First option, benzene. Second option, naphthalene. Third option, anthracene or naphthalene. Let me give you naphthalene. D, all. Okay. Question number 2 is, kids, question number 2. Which is carcinogenic? Question number 2 is, which is carcinogenic? Which is carcinogenic means cancer producing. Carcinogenic, which is being carcinogenic. First option, benzene. Second option, naphthalene. Third option, diphenyl. D option, anthracene. So these are the two questions, fantastic questions, and you have to find out, you're supposed to find out answers of these two questions. These questions are really awesome questions, or you can say examiner's favorite questions. Out of these two questions, this question's answer you will get in your NCERT only. If you search out NCERT, class 11th, let me tell you which NCERT, class 11th second part. If you search out class 11 part 2, you will get the answer of this question from your NCERT only, right, kids? So this is all for today. And for the coupling reaction and Gutterman reaction, whenever we are going to go through in detail, I will let you know the coupling and Gutterman reaction. Two reactions are there. There are also examples of electrophilic substitution reaction. So whenever we are getting time, or if you say, sir, please let us know at least Gutterman coupling reactions, you could let us know later on, but at least let us know the Gutterman, because in IIT this year 4 questions were asked, and there were definitely 2 questions was based on Gutterman only, and NEET also Gutterman reaction has been asked. So let me tell you Gutterman reaction. Should I first do let me know? If you're not tired, then I will let you know what the Gutterman reaction is. Everyone do let me know in the chat section. Yes, Gutterman. Everyone is interested. So please let us know what is Gutterman reaction. So Gutterman is, there are 2 Gutterman reactions. See, everyone focus on Gutterman reaction. If I say there is benzene, if I say there is being benzene, and in both the Gutterman reactions, the target of converting benzene is to benzaldehyde. We are supposed to convert benzene into benzaldehyde. Now, first Gutterman reaction says that react benzene with COHCl and catalyst. COHCl plus catalyst. Now, second Gutterman reaction says react benzene with hydrogen cyanide plus HCl plus catalyst. Now see how many things are common in both the Gutterman reaction. Benzene reactant is common, product is common, HCl is common, catalyst is common. Just CO in this and HCN is this. This is just the difference. You can see the differences of CO and HCN, right? So just remember, in this CO is used, this is known as Gutterman-Koch reaction. This is known as Gutterman-Koch. So how to keep it in your brain? CO, Gutterman-Koch reaction. This is the trick. And here Gutterman aldehyde synthesis. This is just Gutterman aldehyde synthesis. Aldehyde synthesis. Now kids, these are two Gutterman. These are the examples of electrophilic substitution reaction. Both the reactions are example of electrophilic substitution reaction. But there is also one more Gutterman reaction, that is just example of ARSN1. See, what is that? That is not ESR. Benzene disonium chloride. Benzene disonium chloride, when reacts with cuprous powder Cu2Cl2. Cu2Cl2 in presence of HCl, cuprous chloride, HCl, it is going to produce chlorobenzene. This is Sandmeyer reaction. This is Sandmeyer reaction. Let me tell you the difference. This is being Sandmeyer reaction. But if the same reaction is carried out with copper powder HCl, copper powder HCl, this is Gutterman reaction, copper powder HCl. Once again, this is being Gutterman reaction. Now kids, how many Gutterman? 1, 2, 3. Total 3 Gutterman reactions are there. So just keep it in your brain that Gutterman reaction, man of gutter. This is really very, very important. And the last one, these two are ESR reaction, but this is not ESR. This I will let you know ARSN1 when I am going to teach you ARSN1 reaction. And in Sandmeyer reaction, yield is good. Gutterman is poor. Yield is good. So kids, this is all about benzene and derivatives. Kids, bye to all of you. Have a great time. Do the proper revision if you want to get the best rank. All the best, kids. Bye to all of you. Bye. Ayan is saying, sir, mechanism of Gutterman. Oh my God. I was able to see the chat. First of all, let me tell you, the mechanism is not in your syllabus. But then also, if you want to know, let me tell you the mechanism. First thing is that the mechanism is not required. Mechanism of Gutterman not required. Let me tell you very clearly, mechanism is not required. But let me tell you, see, HCN. And why Gutterman is required? First, let me tell you why. What's the use of Gutterman? See, why Gutterman has become famous. If Friedel-Crafts acylation reaction, if I say Friedel-Crafts acylation reaction, we can prepare benzaldehyde. No, the drawback. See, first of all, let me talk about the drawback. That if I react benzene with formyl chloride HCOCl, and we can get formaldehyde, right? That is benzaldehyde we can obtain. Then what was the need? Why we have not gone through this? Why we have prepared benzaldehyde from Gutterman reaction? Actually, this is not stable at room temperature. Not stable at room temperature. And the thing which is not stable at room temperature, so we cannot prepare this. And that's why Gutterman has become famous. So this can't be prepared by like this. Now, Gutterman has used HCN. What Gutterman has used? Gutterman used HCN, HC triple bond N. And what he has used? He has used HCl. So you can see this is negative, this is being positive, and you are going to use HCl. So H will attack over here and Cl will attack over here. What thing you are going to get? You will get HC double bond N, and at this place you will get chlorine. And here you will get nitrogen. So now if this is going to do further hydrolysis, this is going to do further hydrolysis, that on reaction with water, what you are going to get, this is going to react with water and you will get C. You are going to get HCOCl, HCOCl you will get, and ammonia you will get HCOCl you will get, and plus ammonia you have got. Now see, you can see this was not stable. Formyl chloride was not stable at room temperature, but you have prepared formyl chloride. The thing which is not stable at room temperature, you have prepared by reacting these two. And this is the mechanism what not required for your syllabus. Not required, kids. So I can say in Getterman reaction, when no solvent is mentioned, so you can use H3O plus from your side, because this is being the solvent. Whenever the solvent is not mentioned, water is the solvent. So HCl plus water will form hydronium ion. Is that clear to all of you? So what is the electrophile? One kid is asking what is the electrophile. So definitely AlCl3 will take away, see, just HCOCl and hydrous AlCl3 is used, or any catalyst is being used, that will take away its Cl negative and you will get HCO positive as the catalyst. This is the actual electrophile. This is the electrophile which is going to attack. This is the electrophile which is going to attack. Kids, you got it? Everyone able to understand? Have you got the answer, kids? So this question was aspiring medical saying, sir, please take a class of all name reactions. All name reactions class I will take definitely, but this class I would like to take only after all the syllabus, means the whole syllabus is covered by me, because otherwise you won't be able to understand all name reactions mechanism and the taste of the reactions. But so that first, for coming to that point, first of all, let me move step by step through all the chapters. Then definitely that is the backbone of organic chemistry, name reactions and reagents. So after this, definitely I would like to give you all the name reactions along with the reagents. So bye kids, bye to all of you. Next class will be on Monday. Ayan, you can see, you can subscribe the channel and definitely you will come to know that when the days, those days on which I'm having my class, kids, if you're liking it, do comment in the chat section, okay, and share it to maximum of the students, because sharing is caring, and if you're helping out others, Almighty God is going to help you out. And if you're liking this lecture, so always try to share it, kids. Bye to all of you. We'll meet you on next session, right? That is on Monday, right? Monday evening. This day on Friday, I'm going to take classes during daytime, that is in the morning time. But on Monday and Wednesday, I will take your class in the evening. The classes are at 6 p.m. right, kids? Killer Science, today you got late. Killer Science, today you got late. Oh, you must be having your classes. Time duration depends on the class topic. That can be of 2 hours, 3 hours, 4 hours, sometimes 6 hours also. Sometime, wow, Nikhil Mankotia, that's really awesome. Killer Science, you got late, no problem. One kid was asking about the class timing, kid. That depends on the topic, because I have to tell you each and everything, whatever is required for a syllabus, whatever is required for getting best rank. So I never see the time. I always keep on moving along with the flow of the topic, whatever is required. Number of times kids are not able to understand, they are always asking the doubts, so it can take too much time. Otherwise also it all depends on the topic. Some topics are big, some are small, some are very very big. Then we are going to split into one part 1 and part 2, just like GOC part 1 part 2. So it all depends on the topic. So yes, definitely the class duration time is 3 to 6 hours, not less than 3 hours, not more than 6 hours, right kids? Bye to all of you. We'll meet you in next lecture. Okay, anything else, whatever you want, you can ask. We are going to, as a team, we are going to provide each and everything whatever is required for your syllabus. You Ayan, you can see the thumbnail. Once you subscribe it, you will get what? All the notifications, flow of notifications will start coming to you. So you need not to search about when the classes are there. Just, yes, what you're supposed to do, subscribe the channel and automatically you will start getting notifications. So kids, anything else you want to ask kids? Is there anything else? Now see, you are getting each and everything with the best quality. Bye kids. Bye to all of you. Bye. God bless you all.